Perfect. Good, good. So I guess we are live right now. Good. Hello everyone. Welcome to the onboarding session on the Veeam data platform for the Veeam Backup Replication for version 13. Quite a long name we have today. My name is Gabriel, and I'm joined today by my dear friend and colleague Dennis. We are both system engineers here at Veeam, and we'll be responsible for delivering the latest updates throughout this presentation. Speaking of which, it will be recorded. You will receive the recording itself, and you will also receive all the information that we will go over. We highly encourage you along the way, of course. If you have any questions, simply use the dedicated Q&A section, and well, just keep us busy. I will take care of the first part, and my colleague Dennis will take care of the second, since 4 hours of speaking will be quite a lot for only one guy. So with all that being said, I suppose we can jump right into it. I will just make sure to turn off my camera so I don't distract anybody, and we can proceed. So to start with, we'll have the agenda. Of course, we will start with a small introduction on everything that we are doing so far. The architecture and core components, all of those will be discussed as we go, since we need to understand exactly what we will need in order to run a successful backup infrastructure. Next, the advanced feature and the optional components. Not everything is needed when we are discussing about Veeam. From customer to customer, we will have different types of requirements. Based on those requirements, we will also need to use different types of components. A general product configuration, what can be done exactly along the way, the concepts of jobs and the configuration of those jobs. We will slowly move to my colleague's part. The restore capabilities, everything that can be done after a successful backup job. The security of the solution, since security can be quite an important topic nowadays, especially since we are discussing about the rise of ransomware attacks. We will need to ensure that our backups are secure. We need to also make sure that the access to the backup solution is also quite restrictive, and only specific members of our organization do have that specific access. We will end up with some tips and tricks delivered directly by my colleague, and additional resources which can be checked after the session. Maybe sometimes when we have about 10 to 15 minutes one morning, we can open them up and see exactly what's new. Now, introduction. We will have a look at the core capabilities of the product itself, the supported platforms, and of course, quite important as well, the licensing. Veeam Data Platform, it's our flagship, let's call it, is the most important product that Veeam has to offer at the moment. It started only as the Veeam Backup Replication to what we would call today the foundation, meaning we have a look at all the backup needs on a daily basis. Perform backup, we perform restoration. Nowadays, that restoration must also happen in a secure manner, meaning we need to verify what we recover. We also have the on-demand assistance through the AI guidance. And of course, nowadays we also have malware detection capabilities directly embedded in the product. Now, foundation is nice. It's good to have this, once again, daily basis backup and restoration actions available directly to us. But for customers who want a little bit more, we also have advanced available. Now, advanced will allow us to integrate with different security providers from the market. It will also open our door to another solution that Veeam has to offer at the moment, Veeam One. Veeam One is used for monitoring and reporting. It can give you just a singular glass that will allow you to see everything that happens on top of not only your backup infrastructure, but it can also take data from the virtual infrastructure. Let's say we have some Hyper-V or some VMware hosts that they also need to be monitored, or we also require to generate reports on top of them. That can be done through the Veeam One directly. And in the end, for customers that want to be really, really secured when it comes to, let's say, an unplanned event and they need to engage in a disaster recovery scenario, we have the premium edition, meaning the Veeam Recovery Orchestrator becomes available to us, and it can be used in cases where my main data center is down, and I will simply need to use the disaster recovery site in order to continue working. Premium will also have the Coveware Recon Scanner. This is another tool that becomes available along the way. Basically, it's an idea of protecting our data even further with this proactive threat assessment. Coveware will simply analyze what's going on in the background. If something smells fishy, automatically it gets engaged. Now, moving on, we will discuss about the supported platforms, and we will start with the agentless, the virtual platforms. We also call those natives. Now, we started with VMware straight from the beginning. The latest version of the Veeam Backup Replication software supports everything starting from 7 and ending with a 9 from the VMware vSphere perspective. For cloud directors, 10.4 to 10.6. We cannot forget about the Microsoft Hyper-V, everything that is a Microsoft Windows Server 2016 up to 2025 it's supported. And for the Microsoft Azure local fans out there, as it used to be called, the stack, this is supported as well. To us, it appears as a classic Hyper-V distribution. So of course, any kind of Microsoft Hyper-V server is supported. Nutanix, it's another member of this family, with the AOS being supported from 6.8.1.6 all the way up to 7.3. Red Hat virtualization is something that we also support with the 4.4 Service Pack 1. Oracle Linux virtualization, it's also something that can be protected by the VBR software nowadays. And in the end, the Proxmox VE. This is a newer member of the family, as we would call it, since it was a little bit later when we started to support it natively. Up until that point, or for anything that is not part of this list, we can go for the agent approach, meaning we have the workload itself, and instead of communicating directly with the hypervisor, we communicate with the operating system of that specific workload. We can go for the Microsoft Windows Server 2016 up to 2025, exactly as we would do with the Microsoft Hyper-V. Microsoft Windows, everything from 10 to 11. Of course, we can also protect Linux distributions. There are various of them that can be protected nowadays. macOS and IBM are also supported. And in the end, Oracle Solaris for those big customers that do use them. The approach of the agent is we simply install the component on top of the operating system itself. It will appear just as a normal application, we can call it. And then we can utilize the Veeam Backup Replication server, for instances, to perform the backup, taking the backup of those workloads directly to the backup repositories that we recognize through the software itself. We can also go for unstructured data. Each time we have a file share, something coming from the SMB or in the NFS, or we have an enterprise NAS system, something like a NetApp, a Fujitsu, a Lenovo, ThinkSystem. It kind of depends, but the idea is this type of data is highly volatile. It changes all the time. We store new data, multiple copies in some specific areas, and we also require it to have a high access from multiple employees to this data. In that scenario, we can leverage those unstructured data backup jobs, which will make sure that we simply take the files inside that specific file system and store them inside the backup repository. The same can be done but for object storage repositories. Pretty much everything that is an S3 compatible nowadays can work with Veeam. We started slow with the Amazon S3 and the Microsoft Azure Blob, but we moved further. As I mentioned, everything that is S3 compatible, we will have absolutely no issues with them. And the plugins, those are made to be installed on top of specific type of databases, for instance. Now, we discussed about the idea of protecting the whole workload, either with an agent or with an agentless approach, meaning we take everything that specific machine, be that physical or virtual, has to offer. The idea of the plugins will only take specific data. If we are discussing, for instance, about the Microsoft SQL approach, we will only take the backup of the databases which are held by the Microsoft SQL Server Manager, for instance. We have the possibility to schedule those jobs to run at a specific amount of time, or we have the possibility of simply taking them to specific backup repos. When it comes to restoration, it can be done by utilizing the plugin directly. There are instances we also gain some extra features. We can also go for other types of workloads directly from the Veeam Backup Replication console. Entra ID, Salesforce, Microsoft Azure, all of them are available nowadays to be backed up. Pretty much no matter where we have the data, Veeam has a solution for it, and we can perform backups and restorations. Now, we will focus on the licensing part for a second. At the moment, we have two licensing models that are working fully with the Veeam Backup Replication. The per socket or the instance-based, also called VUL. Per socket is the legacy model, as we call it. This is exactly how we went on the market. The idea is we will license the customer depending on the number of the CPU sockets of the host. Automatically, this means per socket can only be utilized for classic virtualization platforms like VMware or Hyper-V, and that's where we stop. So if that's all our environment consists of at the moment, only VMware and Hyper-V, per socket would be the perfect choice. If, on the other hand, we are discussing about the VUL, this is the future-proof model. It's more flexible because this time I'm not wasting my license on top of a host. I'm utilizing my license, as we call them instances, on top of the workload itself. This becomes a little bit more useful because there might be cases where a full host might not be needed to be backed up. For instance, we have 20 virtual machines on top of a host, only 10 of them they need to be protected. In that scenario, I'm pretty much only using half a socket for this operation. If we are discussing about VUL on the other hand, we are discussing about only those 10 instances being recognized by the software and being backed up. The other 10 that I might have at that time can be utilized for a different host, or they can be utilized for a different type of workload, for instance, a physical server or a virtual machine that sits in a public cloud distribution. Kind of depends, but we usually recommend going for the VUL. You never know when you're going to change the environment, or maybe you will need for a couple of months or a couple of years to work with a different environment that moves away from VMware or Hyper-V. In that scenario, VUL is still applicable. Now, we discussed about the licensing models. We can also discuss about the licensing types. There are, exactly as before, two of them, the perpetual and the subscription. Perpetual is the idea of a permanent license. Once we purchased it, it can be used without any kind of interruption. We will need, of course, to renew this license, but if we don't need to access, for instance, the support itself, or we don't want to perform updates of the VPR, of course, we highly encourage you not to get into that situation, then the perpetual might be the way to move forward. Subscription, on the other hand, is the classic approach of the license that expires at the end of the term. You can get it for 1 year, 3 years. The idea is whenever we are getting close to the expiration date of the subscription license, we need to already think about the renewal because once the subscription license is expired, we pretty much cannot do anything with the product anymore. So we need to plan in advance. Good. We will also discuss about the Veeam software appliance now, or the VSA, what exactly it is. Well, so far, Veeam Backup Replication software was an application that was only able to be installed on top of a Windows distribution. Well, not anymore, because we are pretty much coming to Linux. So this is a huge step that we can do nowadays. As you can see on the left side, you'll have the regular VBR appliance, the regular Veeam Backup Replication software, which is installed on top of a Windows operating system. On the right side, you will have the VSA, which is basically the VBR services installed on top of a Linux distribution. This just enough. That's how we should call it. When it comes to accessing it, the classic VBR will need to use the management console, and that will be the only approach when it comes to engaging with the backup services. For the Veeam software appliance, in the beginning, we'll have the web UI that will help me out. And of course, we will also have a management console. So for all the Linux fans out there, or generally speaking, for fans of security, VSA right now can be on a Linux. Good. Now, let's discuss about the maintenance itself. If we are discussing about the regular VBR approach, pretty much only the services and the management console, they fall under our responsibility. So whenever something bad happens with the software itself, that's when Veeam can help. Cannot really help with the operating system, for instance. If we are discussing about the VSA, on the other hand, we are fully responsible down to the operating system of what happens on that part. So when it comes to updates, patches, it's all on us. We can engage with the operating system since, from our perspective, we deliver everything from the operating system up to the application itself. So this Just Enough OS, it's a minimal Linux appliance that we manage as Veeam. All the components that are needed to run successfully in the beginning, they are part of this appliance. Both the Veeam software appliance and the infrastructure appliance deployment, they use this Just Enough OS as the operating system itself. So as I mentioned, all the components are there ready. We have the Veeam services, we have the roles, we have the reverse proxies since we need to use less ports from the security perspective. We have the web host management, we have the updater, which we will discuss a little bit on it a little bit later. And we are discussing about hardening the whole VSA. How we are doing this? Well, we are disabling the SSH first and foremost, since we're discussing about a Linux. We have the DSASTIC derived baselines already present inside the appliance. We have a non-root admin model. We have the security officer feature, which will be discussed a little bit later. And of course, everything is done only through a certificate-based pairing. So this is the highest level of security that we can provide to only the appliance itself that has the VBR services running on top of it. We can also discuss about the high availability. This is something, once again, present only in the newer version of the Veeam Backup Replication software. Exactly as the name implies, the high availability cluster will ensure we have a primary node and a secondary node as well through the use of the classic DR approach. Meaning, if something bad happens with the primary node, we can perform a manual failover to the secondary node without the need of using any kind of configuration restore as we did in the old days. This is something available at the moment in the latest version of Veeam. So whenever we're ready for that, I recommend checking this presentation, maybe once again, having a look on our official user guides, and maybe start performing the transition to enable this high availability to work. Now, we have this Veeam Updater. We discussed a little bit about it in the beginning. The Veeam Updater is our way of making sure that everything that happens on top of the VSA will be updated because it's our responsibility to make sure that everything is working as expected. We have the option to install updates pretty much whenever they appear. We have the option to allow you to install the updates manually, depending on your needs. The idea is the same. It falls under our responsibility. And this updater will make sure to update both the operating system and also the components of the Veeam software itself. In cases where we do not want to have a direct internet connection, we can also use an HTTP proxy. It's completely supported. Indeed, it might also be the case when we need a more precise traffic control. It depends on the type of the organization, and also it depends on the type of security that we want to enforce for the backup solution. Up next, a small differences, I would call them, between the regular VBR and the Veeam software appliance. Now, if we discuss about the regular VBR, of course, everything is Windows based. If we are discussing about any kind of hardening that must happen, of course, it falls under the user to perform it. And indeed, it might take a little bit longer to install if we are not talking about an existing installation already. For the Veeam software appliance, on the other hand, everything is Linux, exactly as I mentioned before. Everything is hardened directly out of the box, meaning we are discussing about the hardening as we discussed in the beginning with the certificate-based pairing, with the hardening of the repository, with the security officer feature. All of those are included straight from day one. Also, it's quite easy to install. We are discussing about a classic image that will be used in the future. When we are discussing about updates as well, in case of the regular VBR approach, we will need to perform all the updates manually, while the VSA will do it automatically using the Veeam Updater. VSA will also have access to the high availability feature. VBR pretty much doesn't have it. Every type of DR scenario must be treated through the classic approach of taking the configuration backup from the main production environment and placing it in the DR site for safekeeping or later use, of course. When we are discussing about management, we need to manage everything through the local standalone in some cases, or in other cases, install the management console on a different machine for engaging with a regular VBR. VSA, on the other hand, will have access to both the management console and the web UI. In the future, it will have a higher coverage as well. And in the end, licensing. The regular VBR can use both the VUL, the instances, and also the socket-based licensing or the perpetual. Indeed, Community Edition can also be used. VSA, on the other hand, will only work with the VUL, meaning only instances will be available. And there is no Community Edition that can be used for the VSA. Now, on the screen, we will have a small picture of the web UI that can be present from the VSA itself. As you can see, it's quite simplistic. I'm interested to see the overview in the beginning, exactly what's the infrastructure health at the moment. Maybe we have some components that require an update or they're simply unavailable. We can discuss about the backups created, how many are clean, are there any kind of anomalies or incidents. We can discuss about the protection workloads. Um, in that scenario, we will also have a look at the immutability status since it's quite a big focus on the moment on the market when it comes to immutability. It's usually the best approach when it comes to the ransomware protection. And the management console or the web UI, of course, since it will have limited features, it looks something like this. Straightforward, just a simple sign in. We need to perform this one in order to gain access to the Veeam services themselves. We can have multiple people that will have different credentials, for instance, in order to engage with the Veeam services, depending on the level of access or their specific role inside the organization. For instance, you might have a backup administrator that should do everything, or you can have just a security officer that from time to time will simply just check how everything's going. Maybe something must be changed in the backend in order to enable some extra features from the security side of things. And the Veeam software appliance with the host management interface. It will just show me some classic information on top of the VSA, like the NTP server. This will be needed along the way when we are discussing about the deployment of the VSA. The SSH server, of course, is disabled by default. That's one of the main rules of the VSA. The networks, we can also set it up manually with an IP from the beginning. The last login can also be checked from this window. We are discussing about users and roles now. We reminded a little at the end of the last slide. We can have the host admin, we can have the security officer, depending on your needs. Straight from the beginning, at least one of each will exist. Now, the host admin is the classic administrator of the host that's running the VSA. The security officer is a specific type of user that has some extra, let's say, features available to it when it comes to some security actions. We are discussing about some sensitive actions that only the security officer can do. Now, we would also discuss about the updater. It can be found over here. As I mentioned, we will just check about those updates directly, and we can install the updates manually or schedule the updates to be installed. Of course, the recommendation holds up as it did in the older versions of the Veeam Backup Replication. Before we perform any kind of update, we will need to perform a configuration backup just to ensure that even if the update goes south, we can still recover and not lose my progress. Now, we can discuss about the architecture and the core components of the VBR itself. We will go around the components themselves, the installation process, the backup workflow, and in the end, we will have a look at the design and an in-depth components breakdown for multiple. So as for the components, we pretty much need to understand what will be the role. If we're discussing about classic management tools, we have the web UI, which is present on top of the VSA only, and we have the management console present on top of the VSA or the classic VBR approach. Both of them will have the classic infrastructure components. The backup server, which will be the brain of the whole operation. It will keep the database for me. It will also make sure that I can engage with the backup services. In some cases, it will also directly have an impact on the backup process itself. It will also be the one who will dictate exactly what's happening. The backup repository, this will be used for keeping my backup points. If we are discussing about full VPKs or incrementals, VIPs, or plugins, or data coming from the cloud, or data coming from a NAS file share, for instance, it doesn't really matter. The idea is the same. This is where my data will be placed inside the backup repository. The backup proxy is also quite an important component of the infrastructure itself. Without the proxies, we really cannot do that much. They're responsible for performing the backup itself. They're also responsible for compression, encryption as well. They all fall under the proxies since they are the main processing units of the whole infrastructure. Now, we will discuss about the installation. We will start with the Windows-based application, meaning the classic VPR that sits on top of a Windows operating system. We will simply need to log in order to gain the ISO file. This can be done by logging in directly on myveeam.com. It's the same place where I will check my support cases, for instance, if I find any kind of updates. I will also have my licenses on this portal. So it's pretty much a universal portal that contains all matter of data and information. Now, we can go with the approach of taking only one specific solution. For instance, in our case, we're discussing about the Veeam Backup Replication, or we can go for a different solution as well. Maybe a Veeam 1, Veeam Recovery Orchestrator. Maybe I want to have all three of them. Maybe I'm interested in a different Veeam product. Pretty much depends on my need at that specific time. Next, I will simply run the executable itself, and I will choose my installation option, the first one basically for installing the Veeam Backup Replication. Next, I will simply go through the classic process of installation. In the beginning, I will simply provide the license file, or if I don't have access to it, it's not a problem. The product is already pre-configured to work in the community edition if there is no license available to us. We will also ask you about updating the license automatically. Maybe that's needed along the way. We will also be able to send proactive support, which will enable usage reporting as well. In the end, we will have a look at the system configuration check, which will see if we have any kind of problems alongside the installation problem. There are cases where we will find some missing components inside this list. We will simply need to address them. So everything is simply passed, it's on the green side, and we can retry the whole process. And in the end, we can also customize the settings. This will be on top of the database. So at the moment, we can go for the PostgreSQL, for instance. This is something that most of the customers are doing. There's also the option for the Microsoft SQL, and we can still move from one database engine to the other exactly as we see fit. In the beginning, if we don't find any kind of instance that we can use, we can simply just install a new one, and it will be used in order to retain all the information about the components, about any other type of, let's say, workloads that we are protecting, like hosts or vCenter, vCenter servers or Hyper-Vs or the clouds. It can also hold data regarding my passwords. If we are discussing about encryption passwords, the configuration database will be the one that will hold them. It will also hold all the data on the jobs themselves, how the backup jobs have been created, replication jobs, how they've been created. Pretty much depends, but the bottom line is whatever happens on top of the Veeam Backup Replication console, it will be 100% present inside the configuration database. Pretty much everything. In case of an emergency, I will definitely need it in order to restore. If I don't have access to it, I pretty much start fresh from the scratch without any kind of possibilities of recovering the old configuration. Now, we discussed about the installation of the Veeam backup replication, the classic Windows approach. We will also discuss about the Veeam software appliance, the VSA. It's a little bit unusual, I would say, since we're discussing about installing something on top of a Linux distribution. So straight from the beginning, it will not look that nice. It's not really that colorful. We're discussing about Linux in the end. We will just select what will be the host name. I would recommend to use a classic and clear naming convention. In our scenario, it will be VBR VSA. So we know exactly what that host does inside my infrastructure. Next, we will have a look at the network. Of course, we will need to specify a network configuration for the system, and the network adapters should be visible to us. We will also need an NTP server, and we will simply just need to specify the time zone. It's quite important inside infrastructure because mismatches can have some really, really weird scenarios that will follow. And in the end, the host administrator. Now, the host administrator that we see over here is basically the host admin, the role that we noticed before. This is the one that will pretty much take care of everything, as in the end, he's the admin. And we can, of course, have multi-factor authentication on top of it as well. And the security officer. The security officer, this one will be in charge of approving sensitive action of the host admins. We go with this zero trust concept, and we are doing this in cases where the host admin credentials are pretty much compromised. In that scenario, the attacker shouldn't have the power to do whatever he wants. He will need to go through all the process of stealing the security officer credentials as well, pretty much. That's the idea that we go for. And of course, we recommend for the security officer to be a member of an information security team. Definitely not from the backup perspective as well. If we can spread out those credentials as much as possible, that would be a good move for the security of our backup infrastructure. And in the end, we will have the summary, so we can move on with finishing deploying the VSA itself. Now, this is how it will look. I will just get the host name, the address, and of course, the addresses for both the web UI and the management console with their certificates as well, which will be later used in order to access the whole solution. We'll also discuss a little bit about the configuration database. So as I mentioned, this one stores all the data of the backup infrastructure of the jobs. It also covers the history of the sessions, depending on how many entries we want to keep. Now, since version 12, VBR can also use PostgreSQL, which can be changed to Microsoft SQL, and the migration it goes both ways. So we can migrate from PostgreSQL to Microsoft SQL, or from SQL Classic to PostgreSQL without any kind of issues. Usually, when we first deployed the VBR, we just place this database locally, meaning on the same machine as the backup server. There are also cases where we will want to deploy it remotely. Maybe the server that runs my VBR at the moment doesn't really have enough resources for going for a configuration database as well. In that scenario, I will keep the VBR on one machine and the database on another machine. Basically, we can say that the configuration database is the way of VBR backing itself up. So the idea of the database is, once again, whenever we face issues, maybe with an update, maybe with an attack, maybe relocating, maybe a DR scenario, we can simply just use it in order to restore a VBR server to another VBR server, to say so. Now, we will go with an in-depth components breakdown. So this is a classic and simple example of a backup workflow. The backup server is the one that will manage the whole operation. It will communicate with the proxies, it will communicate with the backup repository, it will communicate with the production environment as well, with the hypervisor directly. It depends on how our infrastructure is designed at the moment, but the VBR will 100% make sure that all the management is done solely by him. Next, the backup traffic is quite simple. The backup proxies themselves will be the one who will gather all the information from the production environment and will just simply process it and then send it to the backup repo where it's written, basically. The backup server along the way will notice all of those actions. And whenever something happens, the backup server will pretty much get hold of that specific action. Let's say a normal backup job just finished. In that scenario, the backup server will know and it will update its own internal database of that action. One of the restorations are happening, the backup server is pretty much the first one who will know this. We have maybe a failure, let's say at the level of the hypervisor, a snapshot cannot be created. Well, the backup server will be once again informed of this and will know whatever is going on inside the backup infrastructure. We can consider the backup server to be the brain of the whole operation. The backup proxies will be the heavy lifters, the main processing units, and the backup repositories will be the guy that's holding all my backups, regardless of exactly what that backup will contain. Automatically I will have it. Next, we will discuss about the backup proxy. Now, there are multiple types of proxies. We have the classic VMware proxies, which are in charge of performing backup and replication. VMware CDP proxies, which are in charge of moving forward with this specific feature called continuous data protection, or CDP. It's just like a replication, but made a little bit better and more sensitive. Hyper-V proxies, they're also present with the both on-host and off-host approach. Nutanix HV proxies, we call them workers. Red Hat virtualization proxies, we call it the appliance. For the Proxmox and the scale computing hypercore, we will once again refer to them as being workers, but in essence, that's exactly what they do. They just take care of the backup operations. And in the end, we will also have general purpose proxies, which are used for file shares backup, NAS backups, physical servers with off-host backup. Pretty much depends on the type of workloads that we have inside our infrastructure. Whatever it might happen, the VBR is pretty much armed straight from day one with the right type of proxies. So you'll have one VMware and one general purpose. That's how it usually goes. Now, the responsibilities of the proxies, they're usually the same: compression, deduplication, encryption, and of course, the main one, retrieving data from the production storage in order to send it to the backup repository. We are discussing about, of course, a backup operation. If we are discussing about replication, there is also the option to use a source proxy and a target proxies. So instead of communicating with the backup repository, we simply communicate proxy to proxy. This is exactly a classic approach on how the backup proxy will look inside a design of a backup infrastructure. The proxy will have something called data mover. These will also be installed on top of a backup repository or on top of a gateway server. We will learn a little bit later exactly why. The data mover is basically the service that is responsible for the whole movement of data. The proxy will simply be engaged in order to retrieve the data and, through the use of the data mover, send them to the backup repo. It's the most important service, I would call it, this Veeam data mover in the whole infrastructure. Without it, backups will not be possible. Now, we will discuss about the backup proxies specific to the supported platforms that we have at the moment. And we will start, of course, with VMware. The backup proxy that is used in order to back up virtual machines coming from VMware have three specific transport modes. The first one is the network mode. We will start with the network mode. This is the one that will always work because data is retrieved through the ESXi host over LAN using the NBD protocol. This cannot fail. It pretty much works all the time. So it's also a failover option. Now, in case of a normal backup operation using this network mode as a transport mode, the proxy itself will send a request to the ESXi host to locate the VM itself on the data store. Next, the ESXi will simply do that. It will locate the VM. The VBR will instruct the vSphere environment to create a snapshot, which will be, of course, copied by the proxy directly to itself. Next, we will simply just send the data to the repo after we process it. Processing, processing data by a proxy can mean an encryption, it can mean some compression, pretty much depends on how we set the backup job itself, but the proxy itself is pretty much armed to do all of those actions. So that would be the classic approach of performing a backup using the network mode. Everything is done through the proxy. The VBR server itself will also have to communicate with the host. We will see a little bit later on that this might not be needed all the time. The second transport mode is the virtual appliance. The virtual appliance basically can provide better performance than the network mode because this time, instead of keeping the proxy outside of the virtual environment, we simply just keep it as a virtual machine, for instance. That's usually the most approachable way of doing things. Now, in this scenario, the backup server will be the one that will request from the ESXi host to locate the VM on the data store. Next, the ESXi will comply to that request, of course, and it will locate it. The VBR will trigger the vSphere environment to create a snapshot. And this is where the magic happens because those snapshots, basically the VM disk themselves, are attached or hot added to the proxy itself. So it's not a classic read copy operation as we did before. No, we are discussing about hot adding the disks, which of course will be read directly from those disks attached to the proxy. The data will be read directly and will be sent to the backup repository. In the end, when the VM processing is complete, those disks are simply detached from the proxy and that specific snapshot is simply deleted. Now, we need to be extra careful when we are deciding on the transport modes that are being used, because not only, as you can see, they will affect how the backup process happens, it will also affect the performance. The last one will be direct storage access. In this scenario, the VBR will use the classic VMware VADP for a direct VM data transport over a SAN. It can be a classic fiber channel, it can be a fiber channel over Ethernet, it can be a nice SCSI connection, doesn't really matter. The idea is the backup proxy is once again outside of the virtual environment. In this case, the proxy will be the one who will request the VM location from the SXI. Then the SXI will locate the VM and the VBR will trigger a snapshot of the VM to happen. Next, the host itself will retrieve the metadata about the layout of the VM disks directly on the storage. Next, the ESXi host will send the metadata to the proxy, and immediately the proxy will use that metadata to copy the VM data blocks directly from the source storage. So direct storage access will imply that we have direct access to the storage system that can keep the data stores themselves. And in the end, of course, the proxy will simply process the copied data blocks, which are coming from the source storage, and will send them to the backup repository. Now, we will discuss about the proxies that can be used on top of the Hyper-V. Luckily, the number is a little bit slower, it's a little bit smaller. We don't have three modes, I would call them, or three types. We will have only two. Hyper-V work into specific backup modes, the on-host and the off-host. For the on-host approach, the Hyper-V node itself that holds the virtual machines will act as a proxy. It will utilize non-transportable shadow copies by using the VSS itself. So the VBR will simply discuss with the host directly in order to get all the details of their workload that must be pretty much backed up. Next, we will instruct the Hyper-V VSS to create a point-in-time VM copy. This can be done either through a classic VM checkpoint or a volume snapshot, depending on our availability to it at that specific time. Next, the transport service will read the data from the snapshot or from the checkpoint and transfer it to the backup repo. And in the end, after the data is transferred, the VBR will tell the Hyper-V VSS to clean up, pretty much making sure that the whole process is now completed. The backup point was created, and we also cleaned up after ourselves. So this is the on host. Each Hyper-V host will have it available to them, as each Hyper-V host can act as a proxy in the end. The data mover will be present on top of the node directly. But we can also discuss about the use of the off host. Now, in this scenario, we will have a dedicated proxy, which is a non-clustered Hyper-V node. And this time we will utilize transportable shadow copies through the hardware VSS. This is usually offered by the SAN storage vendor directly. So in this case, VBR will do exactly as it did in the past with the on host, and will discuss directly with the Microsoft Hyper-V host in order to get details about the virtual machines that must be backed up. Next, the VBR will instruct the Microsoft Hyper-V VSS to create, once again, either a VM checkpoint or we're using a volume snapshot to create a point-in-time VM copy. And this time, the off-host proxy will be responsible for reading the VM data from the snapshot or the checkpoint and then transfer it to the backup repo. And of course, at the end, the VBR will discuss with Hyper-V for the VSS cleanup operation afterwards. So instead of utilizing the host itself as a proxy, this time we have it as a dedicated workload. Now, we will quickly go over the backup for Nutanix, Red Hat, Oracle Linux, Proxmox, and the Scale Computing Hypercore, since they all share only one singular approach, let's say. It's not like VMware Hyper-V where we get to choose. In those scenarios, we simply deploy the workers or the appliances directly, and we just let them perform the backups. For the Nutanix HV, we will use their native capabilities in order to create image level backups. We will not, of course, install any kind of agent software inside the VM to retrieve data. So using the Nutanix REST API, Veeam will connect with the Nutanix HV cluster. Next, we'll create a snapshot for all the processed VMs or protection domains, depending on how the job was set up. And after that, we will establish a volume group on the Nutanix HV cluster. Veeam will deploy a worker, mounting VM disk to the worker via the iSCSI, and the worker will retrieve the data at the block level. It will apply compression, deduplication, and it will simply send the data to the backup repo. Now, what's interesting over here is to see that Veeam will deploy a worker. Basically, we don't need to have this all the time. We will only use it when needed. And this is something that you will find along the way for multiple supported platforms that we have at this moment. For the Red Hat and Oracle Linux Virtualization Manager, or the OVERT, we follow a similar approach. We will once again use the native OVERT capabilities in order to create image level backups, once again, without installing any kind of agent software inside the VM to retrieve the data. So VBR will be once again the starting point. It will initiate the backup job, transmitting the session data to the backup appliance. This backup appliance is quite important. It's our only method to communicate with those type of environments. Without the appliance, we cannot really see what's going on behind it. Next, the backup appliance interfaces with the virtualization manager, and it will do that using the REST API. It will generate snapshots for the designated VMs from the backup job, what exactly we need to back up. It will establish an image transfer session, and it will supply the corresponding URL. Up next, we will of course deploy the worker utilizing the provided URL in order to retrieve the VM data. And at the end, this worker will perform the duplication and compression on top of the data. And then I will transmit it directly to the backup repository. Next, Proxmox. Again, native capabilities, no installation of an agent software inside the VM. So once again, the VBR will be my launching point. I will simply launch a worker on the host where the VM that I need to back up is located. If none is deployed, it's not a problem. I'll use a worker from another connected host. Then I will connect to the Proxmox VE server and create a copy on write snapshot of the VM that I'm interested to back up. Next, the worker will be responsible for reading the data from the VM disks, compare it to the snapshot created, and exclude any kind of changes. Then we will just transfer the resulting data to the target repo in the native Veeam format. And in the end, I will simply just clean up after myself. I'll remove the created snapshot and suspend the worker itself because the backup session is complete. I don't need it anymore. And in the end, scale computing hypercore. Once again, using the native capabilities, we will just create image level backups without installing any kind of agent software inside the VM itself. So the VBR will simply launch a worker on the node hosting the VM. If they're not available, we will just use another worker or another hypercore node that is connected to the backup infrastructure. We will simply connect to the hypercore cluster in order to create the snapshot. The worker will be the one who will take the snapshot itself. It will just compare it, and then I will filter out any kind of unchanged block. And the result is then transferred to the backup repo in Veeam Native's format. And in the end, we will simply just delete the snapshot and suspend the worker because I don't need it anymore. The backup process is pretty much done at this point. But we discussed about the proxies, what they're doing, how they're doing it, what are the possibilities. We don't really know how to install and configure one. So this is exactly what we'll discuss next. In order to configure or add a proxy, we will just use the VMware example over here. On the left side and all the way down inside the console, we will have a look at the backup infrastructure. Up next, we will simply select the backup proxies, and then we will have a small button to add the proxy. Then we will simply select the type of proxy that we are interested to add. So we can go for a VMware backup proxy, a general purpose backup proxy, or a VMware CDP proxy. Since we are going on the VMware example, we will go with a classic VMware backup proxy, which is used, as the description might imply, for agentless VMware vSphere VM backups. Next, we will simply need to choose the server. We can add it in advance or we can add it right now. It can be a Linux, a Windows. It's up to us on that approach. Next, we will choose the transport mode, exactly what we discussed in the beginning. Direct storage access, we are taking the data directly from a shared storage without impacting the hosts themselves from the production side of things. Virtual appliance, this time I'm passing all the data through the hypervisor IO stack. I'm performing the hot add of the disks directly on top of the proxy or network, which will pretty much work all the time. We are retrieving the data directly from the storage through the hypervisor network stack using the NBD protocol. I am 100% confident that this will work since it's the management interface that will be used. And exactly as you can see, if everything else fails, simply fail over to the network mode. And then the number of the maximum concurrent tasks. This is quite important when we are setting up the proxies because VBR create a task per each virtual machine disk that we are processing. For each one CPU core of a proxy, I will have a maximum of 2 concurrent tasks. And we also recommend to reserve 2 CPU cores and 2 gigs of RAM for the needs of the OS. So if we have a 4-core CPU, we set up, let's say, about 4 concurrent tasks. That would be one approach. For an 8-core CPU, maybe we can go for a 12, depending on the calculation that we want to make behind. Now, why is this important? As the jobs will become bigger and bigger with multiple workloads being included inside them, we will automatically face a situation where I'm facing a bottleneck from the perspective of the proxy, meaning I don't have enough resources at that specific moment to process multiple disks. So what will happen? A queue will be formed at the level of that specific backup job, and I will need to wait for the queue to grow smaller and smaller. In that scenario, I will just move really, really slow through the queue. And of course, the overall duration of the backup job will increase. If that happens, we simply need to just assign some extra resources to the proxy so it can perform the backup of multiple virtual disks at the same time. If we are discussing about Hyper-V, on the other hand, if we are discussing about the on-host approach, we can select how many tasks it can go for at the same time. So this will, once again, dictate how many virtual disks I can process at the same time. This will only be available if the Veeam Data Mover services are present on top of the Hyper-V host, because those services will dictate if it can be used as a proxy or not. By default, when we recognize an Hyper-V host, those services are pushed directly. And the VSA proxy installation, since the VSA it's a little bit more special, we are discussing about the VBR on top of a Linux. Of course, we will have this proxy installation as a separate process. Inside myveeam.com, the same website where we can get all the images, check the support cases, or download the licenses, we will have a dedicated space, let's call it, under extensions and other, where we can see this Veeam infrastructure appliance. It's basically the proxy. Now, of course, it will have its own, let's say, installation process. It's quite complex. Actually, I'm just kidding on that one. It's identical to the VSA, so no changes. We need still to have a look at the host administrator, the security officer, the time through the NTP server, and all of that. So pretty much is identical in the beginning. And the VSA proxy configuration itself, we simply need to add it. That's another thing that must happen. After we prepare it and we install it on a machine, we need to add it to the VBR console. In order to do that, we will simply just choose the server, meaning we need to know the IP or the name of that specific server and specify a maximum number of concurrent tasks. That's pretty much it. Up next, the traffic rules and all of that, they will come as you would like. And there's also the possibility to add as a managed server. This is an optional approach. We have a Linux box, let's say, and we can have it as an extra component in order to work as a proxy as well. That's just another approach that we can go for. It depends on how we want to do it. Good. We should take a 5-minute break right now. After this break, we will just discuss a little bit more about the rest of the components that will be used inside the backup infrastructure. Thank you very much, and see you in a bit. I will just also prepare the timer so it is visible. There we go, and see you in 5. All right, then. Good. So hopefully everybody had their time to grab some coffee, make themselves a little bit comfier than before. So we can proceed exactly as promised with the next set of components that we should discuss. So we discussed the proxies. Now we can move on to the backup repositories. There are a lot of types, depending on our needs, depending on whatever is available inside the infrastructure, depending on how we want things to happen. Not all repositories are created equally. Some are better for keeping data for a longer time, while others are better for keeping data for a shorter time. Some will go in the direction of performance, meaning they move quite fast, while others, they like to have a lot of data stored on them. We will just go through each one of them to see exactly what we should use for what purpose. So a repository is basically a storage location where the backup files, copies of VM data, metadata necessary for the restoration are stored. They can be local, they can be on remote location, they can be in the cloud, they can be pretty much everywhere. And it serves as a centralized storage space for backup and replication data. Now, as you can see over here, we have four main types of repositories that we are working with. Direct attached storages. Those can be just some classic Microsoft or Linux servers. We can also discuss about the Veeam hardened repository, which is basically a Linux server used for storing our backups, which is also made with immutability. So it can provide that extra level of security that we need. Network attached storages. Usually we're discussing about SMBs or NFS shares. Not really the most reliable on the market of what we can use, but through some extra work, they can be quite effective at keeping our backups safe. The duplicating storage appliances, those are usually used in cases where we want to keep data for a longer period of time. For instance, an HP store once, a Dell data domain, an Exacrid, and the list can go on. In these scenarios, we're not really a huge fan of immediate, really fast backups and restoration. We're discussing more about keeping the backups for a longer period of time through the extra deduplication that it can provide. In those scenarios, we will not need to perform the duplication from the Veeam side anymore. So the proxy can simply send raw data. When it comes to duplication, the storage will pretty much do the job for us. And object storages, as I mentioned, pretty much everything that is S3 compatible nowadays can be used with the Veeam Backup Replication solution. We can also remind the Veeam Data Cloud Vault, which is our take on what an object storage should look like. We are discussing about encryption that is enforced at the level of the backup job. We are discussing about immutability that should be present. In those scenarios, the data will reside most likely in a public cloud that will be accessed either through the internet directly or a dedicated line. Just depends on how we set things up. Quite useful nowadays, especially if we are discussing about creating a central point in the cloud for keeping backups from multiple VBR distributions. Something quite effective, especially if we are discussing about a DR scenario. We can simply just restore data from multiple locations without the need of having a physical, a local, I would call it, distribution that will keep those points. Now, the classic approach for a backup repository, and we will use the Windows example over here, is the backup server will have connections to all the components. So it will see the virtual infrastructure that we are trying to back up from. It will see the proxy, which is used in order to process the data and perform the backup itself. And of course, it will see the backup repository. Remember in the beginning when we discussed about Veeam data movers, well, we will not get rid of those services. They're still needed. In some cases, the data movers can be placed directly on top of the backup repository. The Windows has it, the Linux has it as well. In those scenarios, there is no need for an extra component in the middle. The proxy communicates directly with the repository using those services, and the VBR sees everything in the background. So when a classic backup happens, The data is taken from the production environment. It's processed by the proxy. We're not discussing only about sending. We can discuss about encryption. We can discuss also about compression and duplication. And then it's sent to the backup repository. In cases where we need to have a different type of backup repository, like an SMB or an NFS, we will use a gateway in the middle. Now, the gateway is a component that keeps the Veeam data mover service on top of it, because the classic SMB or NFS cannot really do that. So the proxy will take the data from the production environment at the guidance of the VBR server itself, of course. It will process it, send it first to the gateway, and then the gateway will be the one communicated with the backup repository itself. So what we are doing right now, we just simply add an extra component in the middle in order to ensure the Veeam data mover is up and running. In the case of object storage repositories, we can discuss about the use of a gateway or a backup proxy. So all of a sudden, the whole idea of sending data to a cloud-based or an on-premise object storage repository becomes a little bit simpler through the use of this gateway or backup proxy. Basically, we can go for a two-in-one components. We do not need that extra in the middle to act as a singular gateway. Immutability is quite an important topic that I really want to discuss today. Immutability is basically the property, let's call it, of keeping a data safe. How we are doing that? Well, while data is marked as immutable, it cannot be modified or deleted. Meaning, if we are discussing about the potential ransomware attack that will try to come in and encrypt our data, and of course, keeping it for ransom, in that scenario, immutability will block it, since the data cannot be modified. If the attacker will threaten to simply delete the backups, let's say, or there is any kind of accidental deletion that might happen, once again, immutability will protect against this. Whenever we get the chance inside the backup infrastructure to use immutability, we shouldn't pass it. We should 100% go for immutability as much as possible, as it ensures data integrity and security. And as already mentioned, it provides protection against any kind of ransomware and accidental deletions. There are many, many repositories that we can use nowadays in conjunction with immutability. Pretty much the Veeam Data Cloud Vault, it's a clear example. Since I mentioned already, it has immutability. The Veeam Hardened Repository, which is just a classic Linux box that is prepared specifically to have this feature up and running. The Amazon S3 compatible and Azure Object Storage repositories, all of those can have immutability on top of them. And if we are a huge fan of the duplication appliances, HP Store Once and Dell AMC Data Domain, they all have immutability enabled on top of them. We just need some extra configuration from our side so Veeam can effectively use them as well. So whenever we get the chance, once again, let's get that immutability on our backup infrastructure is really, really needed to ensure that even if we have an attack, an ongoing, or a situation where the backup might be accidentally deleted, this immutability will pretty much save me. Now, we will go to the classic example of adding a Veeam hardened repository. So as I mentioned, the Veeam hardened repository itself is just a classic Linux box, which will be used in order to store our backups. In the beginning, we will start with the access step. So the SSS connection will use the single-use credentials or certificates in order to connect to the Linux server. This is done in order to deploy the Veeam data mover. Without it, we cannot really use that specific backup repo. Next, the Veeam Backup Replication, of course, will not store these credentials in the configuration database. They are used pretty much once. And the user account must be a non-root account. Also, it must have the home directory created on the Linux server itself. So that's pretty much all we need to do. From that point forward, we have ourselves a repository, which we can, of course, control in terms of the immutability period. The general recommendation that we come on the market is to make sure that the immutability and the retention period, they are quite alike. If it's possible to be the same, that would be even perfect. In cases where the retention policy is lower than the immutability period, just to give you an example, we store data for 14 days only. That's the retention policy. And the immutability is set for 60 days. In that scenario, Veeam will let us know through messages inside the backup job itself after completion and after a specific amount of time passes that we cannot really apply the retention anymore. So immutability blocks even Veeam from applying the retention, meaning removing some older backup points. If it's the other way around and the retention period is a little bit higher than the immutability period, so let's say we go for 14 days in immutability, 60 days in retention, we get into a situation where maybe some of those points will not be marked as immutable, or maybe we get confused on how immutability works altogether. In that scenario, as I mentioned before, let's try to keep those values as close as possible. Now, making backups immutable with object storage is quite easy. The only thing that we need to understand is we need to do it from the beginning. So when we set up an immutability, it must be done when we create or when we recognize that specific S3 compatible object storage in Veeam. Otherwise, we cannot really engage with it along the way. This is because we might be using object lock and versioning. So those will make my backups immutable. That's true. But at the same time, they cannot be done on the go. So if I already have an S3 object storage and I'm using it for storing the backups, not really many options when it comes to modifying it. I will pretty much need a new one. And we will go to the process of adding a backup repository right now. So on the left side and all the way down inside the Veeam Backup and Replication console, we will have backup infrastructure. Next, we will simply select the backup repositories, and on the left side all the way up, we will have the option to add a repository. We will simply select our type if we are discussing about the direct attached storage or the classic TAS approach. Those will be the classic Windows or Linux repos with internal or direct attached storage where the backups will be kept. Network attached storages, those will be the network shares like the NAS devices or the NFS. The duplicating storage appliances, those will be the classic HP store ones, Dell Data Domain, Fujitsu Exagrid. Object storages, those will be either on-prem object storage system or cloud object storage providers like the public cloud, for instance, Azure or AWS. And the Veeam Data Cloud Vault, it has its own dedicated window for it in order to store your backups over there. So we got the assumption that we went with the direct attached storage. In that scenario, we simply need to select the operating system. So we can go for a classic Microsoft Windows. We can go with a Linux or with a Linux hardnet repo. We will, of course, need to be extra careful with the last approach. We will need a Linux server with either internal or direct attached storage. And in order to minimize the attack surface, we highly recommend to deploy this LHR, as we call it, using the Veeam GOS, just enough operating system image. So we go the assumption that we go for the Microsoft Windows. In that scenario, I will just be asked what will be the repository server. We will also have the button to click, the option to click on the populate button, which will show me the paths themselves, how much storage I have available. Next, I will select the path to that specific folder. Automatically, we recommend it to be created as backups. It's just easier to see exactly what's on top of it. And limiting the maximum concurrent tasks to a specific number. Now, the higher this number, the more troubles I will have from the performance perspective. Maybe I don't have the resources to run that many concurrent tasks at the same time, and maybe I will have IO timeouts. Kind of depends on how strong the backup repository is. We can also perform a limitation on the read-write rate. Pretty much can be needed whenever we are discussing about some slower storages, or we simply need to keep a specific value along the way. Maybe I'm using it for a different purpose as well, that specific repo. Of course, our classic recommendation is to have clear components inside your backup infrastructure, meaning we need to know what is their purpose. So we shouldn't share resources in any way. You can also customize the repository settings. We have the option for alignment. So we can align backup file data blocks. This will increase the backup size by less than 2%, but it will improve the backup and restore performance. We can also decompress backup files data blocks before storing. So remember that we discussed about the data movers in the past. The source data mover, the one that is placed on top of the proxy, or if we are discussing about Hyper-V on top of the host, will compress the data according to the backup job compression settings in order to minimize the LAN traffic. Uncompressing the data before storing allows for a better deduplication ratio. So you can see where I'm going right now. It is a good idea to perform the uncompression before storing, since the deduplication appliance can save up even more space through this option. And in the end, if the repository is backed up by rotated drives, we can use that as well. There are cases where I don't really have that many resources in an offsite or in a dark site. In that scenario, a rotated drive can be utilized as well. Now, mount server, those are quite important. The mount server are pretty much used for advanced restores, as we might call them, application item restore, instant VM recovery, file restores. All of those will require this mount server. Now, the mount server is usually, in about 90% of the cases, the VBR server itself. There are also situations where we want to relocate the mount server, maybe placing it on top of the proxy if we know the proxy is strong enough. The idea is the mount server will be only used in specific types of advanced restores, not all the time. So depending on our uses and depending on our needs, we might need to modify its location. This can be done both for the Windows and the Linux. If we are discussing about configuring the settings, we will of course need to enable the vPower NFS, quite important for instant recoveries of any backups to a VMware vSphere environment. So we have this possibility as well inside the VBR to simply quote unquote migrate the workloads. We simply just take a backup of it and then we can restore it to a different hypervisor, in our scenario of VMware vSphere. The next type will be scale out backup repository. Now, in theory, it's pretty much a storage, I would say, that will keep our backups. But in practice, this storage is actually tiered. So you will see in a second as you have multiple types of tiers that we'll be using. There's three of them. The performance tier will be what we have closer to the data source, let's say. This will be the first point where the original backup job will simply write that point. Then we have the capacity tier. Usually this sits somewhere in the cloud, can be a classic object storage. And the archive tier, this will be used for a longer retention policy and will be used together with the GFS as well. So the classic approach is I will just use something on premises. This will be the performance tier, something that I know it moves fast. Let's say a Windows, a normal direct attached storage that has a really good read-write ratio. In that scenario, this will be my performance tier. Next, I can set a copy or I can perform a move to the capacity tier. That will be another option. And then after a specific amount of time, let's say 150 days or 90 days or 60 days, we can use this archive tier, the Amazon S3 Glacier or the Azure Archive Storage. Now, how do we add a scale-out backup repository? Well, it all starts with the performance tier. Exactly where should we store our backups first? What should be considered to be quote unquote on premises? We will also have some advanced options such as perform a full backup when the required extent is offline. This is used in cases when the repository extent with the previous backup file cannot be reached. In that scenario, the job will perform an active full backup. If we don't want it and we keep it disabled, the job will simply fail if we cannot find that extent. The placement policy, we have two of them, data locality or performance. If we have data locality enabled, all the backup files are placed on the same extent. So incremental backups, they will be stored together with the corresponding full backup file. However, the next full backup file can be created on another extent, except extents backed up by the duplication storage. Of course, that will not work. And of course, the incrementals will be taken with them. So that's what data locality will enforce. We will try to keep the full and the incrementals together. Performance, on the other hand, the incremental backups are placed on a different extent from the corresponding full backup file. This will give me a better backup file transformation performance with raw storage devices. But losing an extent with a full backup will make the restoration process of incremental be impossible, since I cannot really use an incremental without a full backup. And of course, we will have the option to customize this to tell me exactly what will be the placement for both full and incremental backup files. We'll simply allow our users to decide where we should place each one of those backup types. And in the end, we can also enforce this placement policy. By default, when we are not able to place a new backup according to the policy, we will of course violate this specific policy to ensure the backup can still be created. But if we would like to have the backup job failing, we can simply just enable this one and say, no, I really need performance or data locality. So if one of the extents or the backup cannot happen, don't violate anything. I will simply just take a loss on the backup job itself. I will just take the failure. It's completely fine. So that will be at the performance tier part. Now for the capacity tier, we can also, as I mentioned before, extend it and we will have multiple options for it. We will have the copy or the move. Now, the difference between the two of them, the copy will happen as soon as a new job gets done on top of a backup of a performance tier. So basically, let's say I'm finishing the job right now, maybe like 9 a.m. in the morning, something like this. In that scenario, after the job gets completed, an offload happens directly to the capacity tier. So as soon as the original point gets created, a backup, a copy of that specific backup gets sent to the cloud. Move, on the other hand, will say, well, after a specific amount of time, make sure that you move that specific backup to the cloud. We are discussing about both of them, both copy and move at the same time. It means that for a specific amount of time, make sure that we have the data both in the performance tier and in the capacity tier. And after that specific amount of time, it only sits in the capacity tier. We also have the option to override, meaning move all these backup files sooner, so sooner than the duration that we want to select if we go for a space below 90%. And in the end, we of course have the option to encrypt the data that gets uploaded to the object storage, basically the capacity tier itself. And we can also select the offload window and also perform health checks on top of the capacity tier. Now, Shortly, we will go over the Veeam Data Cloud Vault. So this is something that Veeam manages entirely. It provides to our customers with a storage area inside the cloud. And basically, it can be used exactly as you wish. It can be used as a primary backup repo. It can be used as a secondary backup repo for backup copies. It's managed by us entirely. It's secure to immutability and encryption. Encryption happens for both data in flight and data at rest. So not only the traffic, but also the point itself. It's durable since we are discussing about synchronous copies, which ensure up to 12 nines of their ability to protect against any kind of outage and failure. And it's a predictable pricing, inclusive of storage, write and read API calls, and egress fees to eliminate any kind of bill shock. Straight from day one, you will know exactly what you will pay. Now, the Vault itself has two editions that we can use, the Foundation and the Advanced. For the Foundation, we can use it only for secondary backups. Advanced, we can use the Vault as both a primary and a secondary target for my backup. So for both primary backup jobs and backup copy job. As the storage class, both of them will use the Azure Blob Cool storage in order to keep that bill as low as possible. For geo redundancy, the Foundation will go for local redundant storage, while Advanced will go for the Zone 1. For the Foundation, we'll have 11 nines of durability. Advanced will have 12. And of course, Foundation is resilient to drive failure, while Advanced will be resilient to data center failure entirely. For the read or the restore operation of the backup point stored in the vault, the Foundation will follow the fair use approach, meaning up to 20% of the year of the total capacity that we have used so far will be restored for free. Everything that is extra after that, and it will be an extra charge. Advanced, on the other hand, is 100% unlimited, so we can perform read or restore operation as much as we want without any kind of limitation. When it comes to data locality for the Foundation, you will specify the country that you want to go for. Advanced, on the other hand, since it will use the zone redundancy storage, you will specify the whole Asia region that you want to select. Both of them are immutable and both of them are encrypted. So when it comes to the security of the backups, it's pretty much guaranteed in both options. If you want, on the other hand, to control the region, not the country of choice, you should go for advanced. And of course, it all comes down to resiliency as well. Foundation is only resilient to drive failure, while advanced, it's resilient to data center failure as well. Now, the use cases for Foundation and Advanced inside the Veeam Data Cloud Vault. So if we are discussing about Foundation, we can use it only as a copy job, meaning I am already storing my backups inside a backup repo, let's say somewhere locally, and a secondary copy will go to this vault. The Advanced, on the other hand, can be used in order to store the backups directly inside the vault. So I don't need to pass through my on-premise backup repository anymore. I can simply just place it inside the cloud directly. Both of them are based on the Azure Blob Cool storage, so they will pretty much offer quite similar performances, and both of them will have the exact same level of security when it comes to that immutability and encryption at the level of the backup job. This will cover encryption of data in flight and data at rest at the same time. Now, the Veeam Vault, as we have seen before, it has its own dedicated button when we are adding a backup repository. Now, the wizard itself is pretty much straightforward. We will just need to specify the credentials that are used for connecting to that specific Veeam Data Cloud Vault. And the rest of it is pretty much as before. The container will simply let us know what's the folder that we should perform the backup in. The mount server, once again, we will specify something locally, maybe the VBR server itself. It just depends on how we want things to get done. Now, we will discuss about the Share Backup, Share Replica, and the Virtual Lab. This is a set of, I would say, some advanced features inside the VBR software itself. Sure Backup will allow you to perform automatic testing on top of your backups themselves in order to see if you can recover them. You can also perform content scanning. You can also perform some tests if you'd like to do so. And it can also be used in the end in order to use an on-demand sandbox. So the idea is quite simple. We simply create something called a virtual lab. And the virtual lab itself will be powered on behind a proxy. This will be like a virtual environment, let's call it, that has absolutely no connection to the production environment. Next, the proxy will simply set in the middle. We'll make sure that there is absolutely no traffic that is passing through. And we will just take the backups from the backup repo and we'll launch those backups inside the virtual lab. What we will do exactly, we will try to recover. This will be done on top of a host. So those will be virtual machines taken from the backups and recovered using those backup points as templates. In the end, the sure backup will simply let me know how everything went through. So it will let me know which virtual machines we were trying to recover or test, what type of test those machines passed. Maybe some of them passed the ping test, maybe the heartbeat was not that successful. Maybe we also have some scripting in the middle to ensure that we test a specific scenario. We can also assign roles. We can also use application groups. There are a lot of possibilities. Bottom line is, if we have the need to schedule, let's say, a process or a job that checks if my backup points are recoverable, then the sure backup feature is the one that we should have a look at. So quite simple. Let's go over the steps once again. First and foremost, we create the virtual lab itself. Then we create an application group, or we can create multiple. The application groups will be used as quote unquote supports for those tests. Those virtual machines will also be checked, that is true, but we can reuse them in the future. Let's say in order to create a sandbox. We also use them in cases where we'll have dependencies, such as I know I have a database, but the database will get this data from a different server, let's say. That could be an actual scenario. Or I do want to test those servers, but I kind of need a DNS server in the middle as well. In that scenario, the application groups can be used in order to also use those machines and make the test seems a little bit more closer to reality. Instead of performing the restoration and testing it that way, we will simply just use the virtual lab, recycling my backups basically. Then I will create a sure backup job. This will appear as a normal job inside the Veeam Backup Replication software. We will specify what tests should be performed within the jobs. As I mentioned, we can go for the classic ping and heartbeat, but we can also implement scripts in order to see exactly what's going on under a specific scenario. We schedule the sure backup job. We recommend, of course, for this to happen outside business hours, maybe like once per week on a Saturday. That would be just perfect. And in the end, we receive the verification report. This can be received via email, for instance. We can also set on that part. Or if not, you can simply just log in on the VBR console and just have a look manually. Now, there are two verification modes for the Sure Backup functionality: full recoverability testing and backup verification and content scan only. Now, if we go for the full approach, we will just run the machines in the isolated environment in the virtual lab, and then we will perform tests against live application. That's another option. This will ensure that we can recover the production workload in case of an emergency. Backup verification and content scanning, on the other hand, this one will perform backup integrity check and its content analysis to detect traces of malware or any other kind of unwanted or sensitive data. So those type of tests, they do not require setting up any kind of virtual lab. Basically, we don't need to publish anything. Everything happens on top of the backup repo. Basically, we'll just have a look at that data without the need of starting it inside a virtual lab. On-demand sandbox, this is quite an interesting approach. So on the left side, we'll basically have the production network. In the middle, we'll have the proxy appliance. And on the right side, it will have the isolated network. Now, the proxy appliance has the sole purpose of making sure that no traffic passes through. And why am I doing that? Well, there might be at some point a problem with letting the traffic flowing through, because what I'm restoring inside the isolated network, I'm using backups of production of network VMs basically. So when I simply just launch them, I turn them on, they will kind of have the same IPs. And as the network, one of the first rules will say, please don't meet the same IPs twice inside an environment. It's not really a good idea. So the proxy appliance will stay in the middle to make sure that this never happens. If we want to use an on-demand checkbox, all we had to do is at the end of it, after I'm done performing the classic share backup, for instance, just leave it running. That will be an option, for instance. All of those VMs that are inside the isolated network, inside the virtual lab itself, I can play around as I see fit. For instance, I can apply some patches, I can make some modification on some of the VMs, I can try out some extra applications, maybe I need them in the future. I'm too scared to try them into production. And instead of building and maintaining a sandbox, a full sandbox, in order to perform those type of tests, right now I can simply recycle the backups using the Veeam Backup Replication software itself and see exactly what's going to happen if I make specific changes on top of my production environment. Of course, we will revert any kind of changes that will happen. In the end, the sandbox will be powered off, and of course, nothing will be reflected on top of the backup jobs. Next, we will discuss about the storage integration. This is another part of components that we can find inside the infrastructure itself. So we have about three of them that we can talk about: the VMware integration, the NAS integration, and the Veeam agent for Windows integration. For the VMware integration, we pretty much touch on the idea of backing up VMware vSphere VMs using those storages. So this time I'll restore data from storage snapshots with the VBR. For the NAS integration, we will back up the NAS file shares effortlessly. So the idea is I will try to attack, quote unquote, attack the production environment as less as possible. And in the end, Veeam agent for Windows integration, I will just create backups for Windows computers. Now, let's have a look at the infrastructure over here, exactly what it does. So all the way on the right side, I will have the Veeam Backup Replication server. I will have the backup repository and the backup proxies. Now, for the proxy itself, instead of communicating directly with the production environment and bother, let's say, the virtual machines or the file share, this time I will just have a look at the storage volume. I will just create those snapshots, and this one will be used in order to perform the backup. So automatically, my impact on the production environment gets as minimal as possible. Over here, we prepare some timeline representation for the VMware integration. And as you can see over here, the snapshot times, they change considerably when we are discussing about using the storage integration versus the standard VM backup. In the standard VM backup approach, we create a snapshot, we perform the backup, and at the end we commit. But if we are discussing about the VM backup using the storage integration, the lifetime of the VMware snapshot gets considerably smaller, so automatically we speed up the process by a lot. The commitment of the snapshot, as you can see, it's really, really, really low. Of course, we will still go for that storage snapshot creation, but in the end, those type of technologies were created with performance in mind, so automatically it will not take a lot of time to finish those processes. Whenever we can, and if we want to boost performance, I recommend going for those storages. They are worth the investment. So how do I configure the storage integration? Well, it's quite easy. On the left side, all the way down inside the Veeam Backup Replication console, they will have a dedicated button only for them. Next, I will simply just select the storage infrastructure, and then I can add the storage. There are multiple, depending on the type of storage that we are using at the moment. So we can go for the Cisco HyperFlex, IBM Flash system. kind of depends on what we are trying to do. After we select what type of storage we have available to us and we want to actively use with the Veeam Backup Replication software, I will simply need to follow the wizard in order to add the storage. So we are choosing the storage type. This is the first one. Then we connect using the DNS and IPs. We will choose the role. Maybe we are discussing about the integration for the VMware, the integration for the Veeam agents, or a NAS filler. We will add the credentials in order to access the storage, and we will just choose the protocols that we are planning to use. Storage integration can only be used inside a backup job. That's the most important thing. Basically, the technology itself is made in order to improve the RPOs and reduce the impact of backup activities on the production environment, but only if we specifically tell the job to do so. Now, luckily for us, this is a default option inside the software itself. So whenever we are discussing about integration, the enable backup from storage snapshots option should be enabled straight from day one when we create the backup jobs. But I'm sure my colleague Dennis will let you know about this one in a little while. Next, we will move over to the tapes. So this will be a briefly approach. We support native tape operation. By default, anything that's an RTOs 3 to 9, we support without any kind of issues. Nowadays, IBM it's also supported. The purpose of the tapes is to make sure that we meet this long-term data archiving, or we have a specific type of compliance that enforce us to keep data for multiple years. Instead of, let's say, investing on a dedicated storage that will pretty much just keep data for, let's say, 5 or 10 years, we can invest in a tape server and then use those cartridges, as they are also called. After a backup is being taken, we simply just ship them offsite, for instance, in order to ensure that nobody gain an access to them. And we can respect the 3-to-1 rule when we are discussing about the use of tapes. The 3-to-1 states that we need to have 3 copies of data, including production, on 2 different medias, and one of them to be on offsite location. Now, if we are storing our data to a normal backup repo, and then we also implement a tape server that will use cartridges, that's pretty much the rule respected right there. Because first and foremost, we are storing data locally. So that's the second copy. The first one is production. And then we are writing data to tapes, which is then shipped offsite. So we are down to 2 media types, one being a normal direct attached storage, for instance, one being a tape cartridge. And since I can simply ship the tape cartridge offsite, 3-to-1 is fully respected. There are specific supported data types that can be archived using the tapes: VM backups, VM agent backups, entire backup repos that can also be done. And of course, we can also take unstructured data directly to the tape. Now, the infrastructure overview for the tapes, it looks a little bit different, I would say. In order to communicate with the tape library, which is the device that itself writes the cartridges, we will need to have a tape server. And for the tape server itself, this one must be connected to the tape library. By default, in the beginning, when we start working with the Veeam Backup Replication software, and we are interested in using a tape library, usually the VBR itself is a tape server. So there is the option to go with a quote unquote all-in-one deployment and use the VBR as a tape server as well. Or another option, let's just make sure that the tape server is another server with a direct connection, once again, to the type library. Fiber channel, of course, it's preferred since it's one of the fastest. And whenever the backup process happens, the data will be taken from the backup repo by the tape server and fed inside the tape library. Next, the tape library will be in charge of writing that data on the tape cartridges, depending on our options. And in the end, we simply just take out the cartridges and ship them offsite for safekeeping. The next one will be the one accelerator. This is another feature, let's call it, that allows you to send data offsite in cases where the connectivity is not really that good. We can also use it for replication jobs as well in cases where, once again, the connection is not really that good. The one accelerator work as a set, I would call it, a pair of two components. One is the source and one is the target. The source will be in charge of sending the data, while the target will be in charge of receiving the data. Now we have the option to go for two modes, high bandwidth mode and low bandwidth mode. High bandwidth mode is designed to work for one connections faster than 100 Mbps. Low bandwidth mode is for lower than 100 Mbps. In that scenario, we will need to deploy something that we call the cache on the target side. At the first iteration of the job, or we can also engage with this process manually, this cache will be populated. The idea is the cache will be used for future reads-writes operations, so we don't need to send that many blocks of data across the network. If we go with this approach, automatically we can have, even for a lower one connection, lower than 100 Mbps, quite good performances. It depends. And of course, we recommend it to be used only for an offsite. So that would be the best approach. Enterprise Manager, this is a tool that exists on inside the myveeam.com, inside the portal itself. It can be found over there, downloaded and installed. It's free. The idea of the Veeam Backup Enterprise Manager is to ensure that I can pretty much engage with multiple VBRs at the same time. So the Veeam Backup Enterprise Manager has the sole purpose of acting as a central point for multiple VBR distributions. Just to give you an example, maybe I have multiple sites. Each one of those sites will have their own Veeam Backup Replication server. In that scenario, the Veeam Backup Enterprise Manager can be installed on a, let's say, physical or a virtual machine, depending on my needs, and I can realize the connection between those multiple VBRs and the Veeam Backup Enterprise Manager. In that scenario, I will have visibility over each VBR. I can perform restoration, for instance. I can make sure that I give the same license to all of them. So if I have a big license of 100, this will be treated as a pool, and each VBR will ask the Veeam Backup Enterprise Manager for a license, and then this part of the license will be assigned to each VBR. So it's quite a good and useful solution. It can be used by multiple people. That will be another option. We can designate multiple roles, multiple credentials. It just depends on how we want to use it. But bottom line is, use it if you have multiple VBRs and management becomes a little bit clunky. In that scenario, instead of manually going to each VBR, we can use the Veeam Backup Enterprise Manager for that. The installation is quite simple, it's straightforward. It works pretty much similar to how the VBR works in case of in case of an installation itself. We will start with the classic license, and then we will check if we have all the required technologies in order to work completely with the Veeam Backup Enterprise Manager. There are cases along the way where reboot might be required as well. If it's possible, we should allow that to happen. And of course, given the fact that it holds data of multiple VPRs, it will have its own database. So we will need to go for choosing a database engine as well. We can deploy a new instance fresh straight from the beginning, or use an existing one, depending on how we are doing things. Now, this is a deployment example that will touch on the logical relationship between the enterprise manager and multiple other components. So as you can see, we have the enterprise manager, for which the management can be done through the web console. Of course, that will be the only option. The enterprise manager itself will have an enterprise manager database, which will suffer a lot of data collection, let's say, sessions. Through the enterprise manager itself, I can perform management of multiple Veeam Backup Replication server, exactly as you can see here, and I will collect data directly from the databases of each one of those VBRs. So This is how I keep everything up and running, and this is how I keep an eye on all the VBRs, not only managing their consoles remotely. We can discuss about performing a restoration, for instance, but also by collecting data to the database of the enterprise manager from the database of each VBR. So that's how everything is being kept in check. Multiple capabilities on that part to begin with. We will have the summary showing me all the backup servers, all the jobs, the machines, what have happened in the last 24 hours, if everything is okay on that level, how much data we are storing, what's the processing speed and all of that. We can also discuss about seeing the job, maybe starting an active full manually. That will be an option of disabling them, cloning them, or deleting them. And this can be done on top of each one of those VBRs because the Veeam Backup Enterprise Manager will show me in a specific column what VBR has that specific backup job. It will also allow me to perform restoration, exactly as I mentioned. This can be done on top of the virtual machines directly from the Veeam Backup Enterprise Manager. So there is no need to engage with the VBRs manually for this type of procedure. We can perform the restoration over here without any kind of issues. Items can also be checked over here. Maybe you have some mailboxes, some SQL databases, Oracle databases, PostgreSQL instances. Pretty much depends. The thing is, if something was added to the Veeam Backup Enterprise Manager, we can see it. Now, we will simply just need to add the backup servers directly to the Veeam Backup Enterprise Manager so we can see exactly what's going on those VBRs. We can also add the vCenter servers so we can pretty much see that virtual infrastructure as well. And we can engage with the self-service. If we're discussing about vSphere or Cloud Director, we can allow different type of accounts to perform different types of actions. This is quite useful whenever we have a bigger environment or a bigger organization that can also work. And we are trying as much as possible to make each site or each department or each, let's say, company that works inside our organization to act as independent as possible, but also delegate some specific accounts to those people. Next, the roles. We will have multiple roles. We have the portal administrator. This is the classic role, at least one. This will take care of everything that happens inside the Veeam Backup Enterprise Manager solution. Then we have the portal user, just a guy that can browse and have a look at what's going on around the console itself, and the operator. The restore operator will be able to perform restoration whenever we want to do so. Of course, there are multiple types of options of adding roles. We can add them at the level of individual users and just go one by one. We can go at the level of a group. Maybe we're discussing about some external users or group, or directly from a vSphere role. And then the three roles that we can have inside the Veeam Backup Enterprise Manager, as I mentioned, the portal administrator, the portal user, and the restore operator. Now, for the settings over here, we will have the keys management in this sphere. And this will allow me, in cases where I'll forget what is the encryption password on top of a VBR, to use this functionality in order to generate a recovery token. Basically, this will be a one-time pass to ensure that we can still recover even if I forget those encryption password. Quite useful, and I recommend whenever we are discussing about encryption at the level of the VBR to make sure that Veeam Backup Enterprise Manager is also in the play. So if we forget what that password might be, at least we will have the option to generate that recovery token. The process itself is quite simple. I will just go back a slide for a second. I will just generate one of those small tokens and use it whenever I perform the restoration and I don't remember the password. And as long as that specific VBR is seen by the Veeam Backup Enterprise Manager, everything will go smooth. Licensing, as I mentioned, everything will happen from the Veeam Enterprise Manager. So whichever server is connected directly to the Veeam Enterprise Manager will ask for licenses directly from it. It depends on what we have at the moment available to us. For instance, one VBR might ask only for 5 instances, the other one will ask for 150. it pretty much depends on their use, but each one of them will refer to the Veeam Backup Enterprise Manager for their licenses. If we will try to deploy a local license on top of a VBR that was already added to the Veeam Backup Enterprise Manager, and the Veeam Backup Enterprise Manager is the one that should manage the license, each time a job will run, the Veeam Backup Enterprise Manager will supersede the license that is part of the VBR. So extra careful when we are performing the management of the license from the Veeam Backup Enterprise Manager, because unless that VBR is not taken out from the Veeam Backup Enterprise Manager window, we cannot really engage with any change of license. You can also generate a report to see exactly what is being used. So those will be the name of the instances in my scenario and the job themselves that cover those instances. Good. That will be pretty much everything for the moment. We will just take a quick 5 minutes break. And after the break, I think you will just meet up with my colleague, Dennis. Let me just
That's right.
prepare.
That's right. Thank you so much, Gabi. Great presentation and very valuable information. So yeah, let's take a 5 minute break. I will steal the screen sharing from you to put the timer now. Let me just
That would
see
be
if
perfect.
it's okay. All right. Okay. Oh, maybe you can do it. It seems that I'm having a small technical issue.
All right, I will just start it from my side. Good. So I suppose we have about 5 minutes to fix it at the moment. We'll be right back, folks. Thank you.
All right. Can you confirm if you can see the screen and if you can hear me well? Okay, great. I guess it's working well. Great. So let's just continue the presentation. Let's continue the training. The next part of the training, in the next part of the training, we're going to talk about the main menu and we're going to explore the main menu, but we're also going to cover the backup functionalities, how to create a backup job, um, the restore functionality, how to restore the data, which is pretty much the most important thing that we have out there, right, for the backups. And we're also going to cover the malware detection mechanisms, the security features that we have, um, plus some additional information on how you can get certified and what you can do with how can you can enrich your Veeam knowledge. So let's dive right into it. Um, the main menu is in the top left corner in that burger menu in here, right? And the first option that we're going to explore is credentials and passwords. We have four options in here. The first one is data center credentials. Pretty self-explanatory. It's designed to view and manage saved credentials and private keys and tokens for your infrastructure. We then have the cloud credentials to manage, view the saved cloud accounts and access keys for your cloud integration. We currently have integration with AWS, with Microsoft Azure, and with Google Cloud, so you can protect those native infrastructure items natively with their own native integration. Encryption password, passwords that will maintain a list of the passwords that you plan to use for the data encryption, and the key management servers, where you can add KMS servers and manage the KMS keys just as well. The next option that we have is users and roles in here. You might have noticed that we're not going to go straight down, but rather we're going to pretty much jump around in here. If any questions pop up in the meantime, please feel free to use the Q&A chat, um, and my colleague will be more than happy to answer those questions. Right, getting back to users and roles. Here, the first thing that we're going to see is a list of the users that we have alongside their roles. Um, and for us, you can see in here that we only have one user that is a Veeam backup admin. Um, you can easily add new users or new groups. All you need to do is just specify the user by the domain /username, or you can even browse it and you can add it in here while you also specify the role that you have for the user. The current roles that we support are the default actually roles that we have are restore operator, which allows the restoration process to be performed by a specific user or user group. Backup operator, which will be handling the backups but doesn't really have the permissions to do restores, so you can split this responsibilities. Backup administrator, which is able to perform all administrative activities within full access um, to everything that's added to the backup infrastructure. Tape operator, as my colleague mentioned before with the tape integration, this role can handle the tape operations that we have. And backup viewer, which can only see what's going on in the console but cannot really modify or restore anything, so it has read-only permissions. But the thing is, with version 13 now, we have also released our role-based access control feature that will allow you to create custom roles to assign to specific users, so they can have specific access, granular access to your infrastructure items. Control access can be given to backup and restore operators, operations, repositories, infrastructure items, even remote console UI options. And the supported workloads here are VMware, Hyper-V, Windows and Linux agents, unstructured data, and database plugins. As you can see in this screenshot in here in this picture, you can give it a name, inventory scope, repository scope, and then you can select the restore permissions that you have, so you can go more granular. The next topic that I want to cover is network traffic rules, which are pretty important, right? Keep in mind that by default, Veeam will use multi-threaded data transfer for every job session from source to target over the TCP/IP connections. However, if you feel that you need to schedule several jobs to run at the same time and the load on the network is heavy, you can always just disable this option, or you can lower the upload streams that you have available. Nonetheless, you can always configure your own networks. All you need to do is just click add, and you can select the IPv4 or IPv6 networks that you want to add. And here is a nice picture on how those network configuration steps look like. So we can give it a name, of course, select the source and target IP ranges. And then we have the advanced options on encrypting the network traffic. So yes, it is that simple to encrypt the network traffic and to throttle the network traffic to the desired amount. And you can also specify a backup window or a window in which this network should be throttled. Just so you know for sure that even if your backup jobs exceed into the business window, for example, they're not really impacting the production network that you have. New in version 13, we have also added the option to select preferred networks for your backup operations. It works, it's fully supported for backup and for replication operations and traffic. So you can design your own network the way you want to. Global exclusions, I feel like it's pretty self-explanatory. This will allow us to select specific items that are going to be excluded entirely from the backup and from the replication console. So you're not going to work with them, even if you have a tag-based schema on the backup jobs, right? Those are going to be excluded by default. We also have the malware exclusions in here, and we're going to explore there in a couple of slides later on during this presentation, right? Options. Now, under options, we have multiple tabs that we can pick. The first tab is input and output control. Now, when storage latency control is enabled, Veeam Backup Replication will monitor the storage read latency on production data stores using real-time metrics from the hypervisors where VMs reside. And we do have multiple options in here. Of course, the first one is whether to enable it or disable it. And then you can assign different values for stopping assigning new tasks to data store a specific latency value, or throttled the existing traffic um, when you reach specific latency values. The next option that we're going to cover is email settings, and we have skipped over the security. You're going to see later on why. We do have a specific chapter in this training focused on security topics, so we're going to cover that later on. Now, under email notifications, under email settings, we can actually instruct Veeam to send us email notification based on what's happening in the backup console, right? At the moment, we support SMTP, Google, Gmail, and Microsoft 365 as the mail servers that can be used for this purpose. And you can choose your own addresses that you're going to work with, and of course, the subjects. You can schedule the daily reports to be sent at a specific time that you prefer. Maybe you prefer it to be sent, I don't know, in the morning, so you can have a look over them when you sip your coffee or your tea. And you can adjust the notifications. You can have success warning failure or suppress the notifications until the last job retry, which we're going to cover later on when we talk about backup jobs. Notifications is also a big part of the Veeam backup and replication. We do advise to use Veeam for notification, alarms, monitoring, and reporting. However, we do have some basic functionality in here as well. The reason why I said that it's a big tool, a big feature that we also use, is because it can alarm you when disk free space is low. You can adjust the threshold yourself. And it can also warn you about production data stores in here. If you choose to, you can also have notifications being enabled when support is supposed to expire. Under history, we control the number of sessions that we can see in the history tab of the backup and application console. And we can also adjust the retention that we have. So how long do we want to keep and how many sessions do we want to be able to see in that menu? right? This doesn't erase the event viewer logs that we have on the Windows backup replication servers, right? It's just going to handle those entries under history, session history in the Veeam backup replication console. Now, if you need to launch specific consoles such as PowerShell or the PuTTY utility, you can actually do that directly from the console. So you can select the top left corner burger menu and go to consoles. And we also have Swagger in here um, for the REST APIs documentation. On the next topic, we're going to talk about configuration backup, which is really important because this is the tool that we have on creating a backup of the already existing configuration, right? So basically here, what you can do is you can enable it. This is definitely one of the best practices that we have to have it enabled and stored in a remote location if possible, right? So don't store it on the same repository that is connected to the VBR server. You can choose how many restore points or how many versions of this configuration to be kept. And you can also choose when you want to perform it, which is going to also show you the last successful backup, right? You can select, of course, the repository and the notifications in here. And another important bit that I have in here for you is enabling the configuration backup. Make sure that this file is encrypted because basically what we're going to do is this with this file is in case we lose access to the VBR server, we can use this config file to restore it back to a um, freshly downloaded and installed VBR, and we're going to have everything back on track. Basically, we're going to have the configuration back without going through the hassle of reconfiguring everything, right? Next, inline jobs. So what are these jobs? Well, in Veeam Backup and Replication, those jobs encompass a range of data management tasks, including backup, replication, and restore. Those are basically the instructions that we have on how to collect the data, how to manipulate the data, how to store it in order to make it available whenever you need to for the restore or failover operations, right? When it comes to backup infrastructure resource allocation, there is the resource scheduler service within Veeam Backup application that will identify the priorities of the jobs. So let's explore a bit those job priorities and the prioritization that we have, right? So here's a simplified list of those. First, we have the data restore jobs. It makes sense. A backup is as good and as valuable as the restores are. So we need to make sure that we prioritize restoring the data first so you can retrieve it. Most likely, if you need to restore the data, some files are being lost or even something bad has happened. Continuous data protection policies take the second place in here. After that, we also have the background system jobs, such as a snapshot deleter, for example. And then we have the quick backup jobs. We're going to cover those quick backup jobs in greater detail later on. And then we have the high priority jobs. We're going to have a look at how those jobs are being created, how you can configure your own jobs, and you're going to see where this button also resides and how you can work with it. And only after all of these, we're going to have the regular backup jobs and replication jobs, right? Those are followed by the copy jobs and archive jobs. It makes sense. We need to make sure that the data is available first for us to be restored, that we're not impacting the production in any way possible. If we have something that is high priority for us, we're going to prioritize that before any other backup jobs. Then we're going to do the backup and the replication, followed by the backup copies and the archive jobs. Now, let's have a look at how the backup process looks like, how we do the backup of the virtual machines that we have, right? So first we have the backup server in here, we have the hypervisor, the backup proxies, the backup repositories with the data mover services that my colleague Abby mentioned earlier on. And then we have the configuration database in the backup service, which are part of the Veeam backup application. Keep in mind the configuration database doesn't have to reside on the same server. It can also reside on a different server. Now, when we trigger a backup job, when we start a backup job, first we're going to start the Veeam backup service, which is going to create Veeam backup managers, right? So for each job, we're going to have a Veeam backup manager. This manager's role is to actually read the job settings from the configuration database and push those settings, those instructions to to the data mover services, so they know exactly what the rules are and what they need to do. The fourth step in this diagram is for the backup server to request a point in time creation to the hypervisor. We're talking about a snapshot or a checkpoint, right? Um, After the snapshot or the checkpoint is created, we're going to proceed with the data transfer process, right? So the proxy is going to collect the data from this snapshot and it's going to place that into the repository. We're going to compress it, deduplicate it, and even encrypt it if you have that setting enabled. So let's have a look at how you can configure those backup jobs. So primary, the first thing that we see when we try to create a backup job is the naming convention, where we give it a name, even a description. And then you can see in here that after the description, we have the high priority check mark, the button, which is going to prioritize this job in front of the other backup jobs. Then we can add the virtual machines. Adding the virtual machines is again straightforward. On the right hand side of this picture, we have the add button, and we can choose how we want to add those virtual machines. We can either have this view by hosts and clusters, by virtual machines, by data stores and VMs, of course, and also by tags or tag combinations, which is pretty much the last one that we have in here. Under exclusions, we can set up what do we want to exclude after adding our virtual machines. You can see we have two of them added in here, and we can choose whether we want to exclude some specific VMs, some specific disks, or even templates in here. This is helpful, especially when you want to add an entire data store into the backup job, or when you want to add the host itself with all of the subsequent virtual machines, or even specific tags, right? Now, the next option that we have in here is the storage tab. In the storage tab, we can choose the backup proxy in here. By default, is going to be on automatic selection, but we do have some recommendations on the backup proxies that you can use. And you can select them in this window after clicking choose, of course. And then we select the backup repository, right? Which also shows us the available space that we have for this backup job. The next thing that we need to worry about with this backup job is the retention policy. And we have two types of retention policy in here. So we have the first one, which is 7 days of retention in here. This is actually the short-term retention that we have. Um, and then we have the secondary one, which is actually the long-term retention, which is designed to keep data for weeks, months, or years. As you can see in this smaller picture, we can choose to keep certain full backups for 4 weeks, 12 months, or 13 years, for example, we have in here. Now, keep in mind that Veeam is not going to create an active full backup or a full backup for all of those settings that we have in here. Rather, we're going to flag the already existing full backups just so we don't really double the amount of capacity that you have on the storage units. When we're talking about capacity, we're also talking about object storage that you can use, and we definitely don't want to have you any additional costs just because you need to keep some backups longer. That's why we have these options in here. If multiple full backups exist, use the one from Sunday, use weekly full backups from the following week of the month, the first Sunday basically as a monthly, and then it goes the same for yearly. Right. If any questions pop up regarding the, I don't know, retention policies or the GFS, feel free to add them in the chat, in the question box. Now, let's explore the advanced job settings, because at some point during this presentation, I mentioned that you can have encryption as well. And we're going to get to that in a couple of seconds. The first options that we have in here are the two options to create a full. So we can have a synthetic full that will be created or an active full. Now, the main difference between those tools is with synthetic, we're actually going to have the IOPS on the repository, right? And with active folds, we're going to have the IOPS on the production data store. So what does it mean? Well, let me take it with the second option in here. So let's explore the second option, the active fold. During the active fold, we're doing a full disk read in production, and we're just taking the data, compressing it, duplicating it, encrypting it, and storing it into the repository. So the IOPS are massively on the production data store. Whereas with synthetic, during the synthetic full, which is a Saturday in our case, We're going to run an incremental file. So we're going to read the change blocks that we have since the previous session. And we're going to synthesize a full out of the most recent blocks of data on the repository. That's why these will shift the IOPS on the repository themselves. Keep in mind, whenever you trigger a job, whenever you start a job, the first run will always be an active fault. It makes sense. It needs to actually initialize the data, right, that we have to have a starting point. Next in line, we have maintenance, where we have the storage level corruption guard. So, so what we can do with this option is we can set a health check to be run against the data that we have into our repositories, which can be run once a month or even weekly if that's what you're looking for. And it's designed to detect and auto heal corruption of the data. Now, it doesn't happen frequently that we have corrupted data or incomplete data, but sometimes it can. If there is a, I don't know, a disk failure, we can end up with an incomplete incremental, which can be healed later on. If there is an unexpected failure on the storage side or on the production, even a power outage, we can end up with a corrupted um, backup, which can be auto healed by this function. The next options are full backup file maintenance options, which we can design to remove deleted items after a specific number of days. And we can also choose to defragment and compact the full backup file on the repositories on a specific day, just so we kick the performance up a notch if it's required, of course. Now, under storage, this is pretty much where the magic happens. So we have all of these data reduction options to enable inline deduplication. So this is the duplication that I was talking about. To exclude the swap file blocks and exclude the deleted file blocks. Those are not necessary. Those are not needed to be backed up usually, and they only occupy space on the repositories that you choose. And then we have the compression levels, which you can set on optimal, which is definitely recommended, but you can also go with the tube friendly for the duplication appliances if that's the repository that you choose. Storage optimization, again, the size of the blocks that you're going to work with. And at the lower half of this window, we do have the encryption, which I mentioned a couple of times up until now. So you can set up the encryption, which is going to encrypt the backups at rest. Keep in mind that with Veeam, we have these two types of encryption. Encryption in transit, which is what we covered when we talked about the networks. And then we have encryption at rest, which is this one right here, meaning that we're encrypting the data as we're writing it to repositories. The only repository where I would not recommend using encryption is um, a deduplication appliance, right? Because it can mess up with the deduplication process that we have in there. The next tab in here are the notifications, where you can set the SNMP notification or email notifications. Um, those are slightly different than what we have with the global notifications, because those can be different from the global notifications. If you set up any notifications in here, those are going to overwrite the global ones for this particular job. So you can have um, a different notification schedule in here. It has the same options as we have explored into the global notifications. We can either choose to use the global notifications or custom notification settings with success, warning, or errors, even suppress them. And something that you can also do is set successful backup details to this VM attribute, right? So you can append this to the existing attributes value. The next option is vSphere. So we do have the first option in here, guest quiescence, which is going to leverage the VMware tools quiescence. Um, these native quiescence will only be used for VMs with application aware processing disabled. Application aware processing will be found into the guest processing, which is our next topic. Um, you can keep it enabled. It's not going to take any effect if we have the guest processing enabled. However, I usually do recommend using guest processing and not VMware tools quiescence. Not that it's not a good feature. It is a useful feature. However, you can actually choose one or the other. Now, the next option in here are change block tracking, where we can enable CBT for all protected VMs. This is helpful because we're going to leverage a change block tracking driver in the VMware, or basically in the production infrastructure, to help us identify faster which are the blocks of data that we need to archive to repositories. But of course, we can also select to reset the CBT on active full backup files. By default, active files will not use CBT, so that's why we can reset it right there and then. I remember that Gabi talked to you about the storage integration and kind of let you know that we're going to cover that later on in this part of the presentation. This is where you can select the primary storage integration and you can enable the backup from storage snapshots. You have multiple options in here that you can use. One of them is limit processed VM count per storage snapshot to a specific amount. You can fail over to standard backups. If you remember the diagram that in the pictures that Gabi presented, we're going to use the standard snapshot only for a limited amount of time, just for us to have a successful tiny bit of a freeze for the VM so we can take the data consistently. But if those storage snapshots fail, you can always just fail over to standard backups. There's also an option to fail over to primary storage snapshots, so you can also utilize that. The last option into the advanced settings are the scripts, where you can choose to run specific scripts before and after the job, so you can prepare the virtual machine for taking the backup, right? For processing the backup. You can run the scripts every backup session, or you can also choose to run the script whenever necessary. Um, the next option that we have is guest processing, right? This is the option that we're going to use whenever you have a application um, that we need to back up. The applications supported are from the Microsoft suite. We do support Active Directory, Exchange, SQL databases, but we also support Oracle, PostgreSQL just as well. Um, so what we need to do is we need to enable those two options. Basically, the first option is enable application word processing, which is going to detect and prepare the applications for being backed up consistently. By default, Veeam will do a crash consistent job, which is sufficient. But when we're talking about sensitive applications, we can actually involve transactional processing and OS configuration to make sure that we have the data consistent in the backups. And then we have the secondary option there, which is guest file system indexing. But let's talk about application word processing first. So what I'm going to do is we're going to click on application handling options, and we're going to have this option popping up, which is going to show us the virtual machines that we have added in this job. Under the general, basically, if we highlight one of the virtual machines and click on edit, we do have multiple options of guest processing in here. Yes, all of them are available, even though we don't have all of these applications on this virtual machine. So don't be scared by that, right? Under applications, we can choose whether we want to have successful require successful processing for the application, or we can try application processing but ignore the failures. In this case, we're instructing Veeam that, hey, I'm okay with having a crash consistent backup as long as I have a crash consistent backup, right? And you can also choose to disable application where processing. You might ask why. Well, you might have multiple virtual machines in here that don't really require any application where processing, so you can disable for those machines that don't, right? We also have the VSS settings. By default, what we're doing to clear the data is we're injecting some temporary runtime components, which also contain some VSS framework and some VSS technology that we're going to leverage from within the servers themselves to actually produce a transitionally consistent backup. And you can choose whether you want to process transaction logs or just copy them. The last option in this menu is persistent guest agent. By default, everything that we do during guest interaction is pretty much temporary. Basically, we're pushing some non-persistent runtime components that are going to be utilized for the time of the backup, and then they're not going to be present on the machine anymore. But if you choose to, you can always choose a persistent agent, which is going to be utilized every time that we need to do uh, a consistent backup. We're going to explore the next options, and then we have the SQL option. So if you know for a fact that this is a SQL database, right, we can choose to truncate the logs, do not truncate them, or back up the logs periodically. And we can choose how often we want to back up those logs and how long we want to retain them. This is useful so you can revert the database, you can restore the database and revert it back to a specific point in time that you choose in here. Same options are available for Oracle just as well. You can back up the logs. Um, and you can choose how long you want to keep them. PostgreSQL just as well. And we also have specific exclusions in here where we can choose to exclude some files and folders or include them if that's something that we need to do. And also scripts. So for those applications that are not natively supported by Veeam, you can also use your in-house scripts to prepare the application and to actually back up the application itself and the logs that you have in there. Right, next option in here is enabling file system indexing and malware detection. So what this does, this is going to enable a global file search functionality by indexing all of the files that you need. This is also provided by Enterprise Manager, which is one of the slides I believe that Gabriel also has. So this is where you can enable that feature. Of course, we will also need to have a component to connect to those guest OSs and to push those runtime components. And this is the guest interaction proxy that we have in here. So you can choose a specific proxy or you can leave it on automatic selection. And in order for us to connect to those guest OS to do the application we're processing, we need to have some credentials, which need to have admin rights, and they actually need to be able to connect to the admin share of the machine itself. In order for us to make sure that the OS, that the credentials are right, we can also verify them, and we can also set them up for individual machines right here with this button. The verification will happen at the next button where we also verify the connectivity that we have to the virtual machines prior to having any failed jobs because we have any connectivity mismatch in there. After selecting the virtual machines, the storage, the guest processing, we need to schedule the job. So we can schedule the job to run daily, monthly, periodically, or after a specific job. So you can choose how often you need this backup job to run. We also have the automatic retries. So in those cases where virtual machine becomes unavailable or something happens and that virtual machine could not be backed up properly, we can allow the job to retry. You can adjust those retries. By default, we have 3 retries with 15 minutes between each other. Just so we allow some time for the virtual machine to be reconfigured in case there is an outside, I don't know, an outside of Veeam process that gets in between. And this is also the place where we select the backup window, which is designed to terminate the job outside of the allowed backup window, the permitted time. Let me just show you exactly how the window looks like. If we click on this window button, we're going to have the smaller this smaller window, which is going to ask us, okay, when do you want to permit? With green, we have permitting, the backups to run. Then with gray, we have denied it. So you can see that in this example, we have denied this job to run from 8 a.m. to 8 p.m. Monday to Friday. So pretty much business time, right? After configuring the job, we have the summary where we need to review all of the um, backup configurations, and then we can choose to run this job after clicking finish. By default, the job will be configured but will not run until the next scheduled time. So you can choose to also run the job. I believe it's time for a 5-minute break, and then we're going to discuss about restore options. So let me just start a timer and we can just go on that break. Oh, here it is. All right, let's get back to the presentation and let's start with the restore topic that I promised you already. Okay, so Veeam will allow you numerous restore options. You can pick from numerous restore options. And we do have positioned in such a way that you can understand exactly how they work or what you can do with them, right? So first we have the instant recovery options in here that will help you instantly recover a virtual machine or even some disks. So you can minimize the RTO into um, recovering the data, fully accessing the data from the backups. And then we have the on-prem recovery options, restoring the entire VM, restoring the virtual disks, contents, uh, VM files, the files that will create a virtual machine, such as the VMX file, and so on and so forth. And then restoring the guest files, right? So the virtual machines from within the OS of the files from within the OS of the virtual machine. Next, we have the cross-platform restores, where we start with the entire VM restored to Nutanix, or you can also restore some virtual disk to Nutanix, entire VM restored to Proxmox, and also cloud integration. We like to call these options cloud mobility and even data freedom because Veeam will allow you to recover the data um, from on-premises to cloud, from cloud to cloud, and from cloud to on-premises back. So you can shift your data however you want without being locked into a specific environment. We also have the advanced options on moving the backups, copying the backup, exporting them, or even scanning them with the malware options that we have out there, and also deleting them from disk if those are obsolete backups that you no longer need, right? About the last two, we're going to cover them in a couple of minutes. But let's focus on recovery options for now. So let's start with instant recovery. Well, as I previously mentioned, with instant recovery, you can almost immediately restore a virtual machine into your production environment by running it directly from the compressed and deduplicated backup file. The way that it works is we're going to take the backup and we're going to mount it as a NFS data store. So in a scenario where the virtual machine is unavailable, we can take the backup from the backup repository and mount it with a vPower service as an NFS data store to the ESXi host. Um, and then we can have the virtual machine back and running. Now, this is a virtual machine that's running entirely from the backup file. You can still browse it, you can still work with it, but just keep in mind that it's still running from the backup file. And you can finalize this process in two ways. You can either just do an online migration of that backup to your production infrastructure, or you can browse the files that you need or do the verification that you wanted to do in the first place, and then you can stop publishing those virtual machines with the vPower service. The next option that is more popular or growing more in popularity is restore to Amazon, Azure, or Google Cloud. Now, the way that we work is we can restore from on-premises. You can see we have the backup replication, the backup repositories in here, and we can restore from on-premises um, to the cloud infrastructure. The way that we do is we use this restore helper appliance, which is an additional component. It's basically a Linux VM that runs in the cloud, and it's there to help us migrate the data, uh, con, um, help us transform the data so it can take effect as a cloud virtual machine. So the way that we work is we back up the repository, we take the data from the backup repository and we restore it through the helper appliance as a cloud virtual machine. Now, a few important bits in here. Be mindful that the helper appliance is temporary on Amazon and Google Cloud, but with Azure, we need the helper appliance because these are mandatory and persistent, right? Um, when this helper appliance is not utilized in Azure, it's just going to be powered off, right? And it's going to um, be powered on again when you need to do another restore process. The next, the next slide will present the guest file restores. So how we can recover specific files from the backups that we have taken of the virtual machines. So it's possible to restore those specific files from the OS without restoring the entire virtual machine or the entire physical server. The supported sources are backups, replicas, storage snapshots, and Nutanix AHV snapshots. And we do have the following supported file system in here, right? With Windows, Linux, Mac, Solaris, and BSD, right? Now, the way that we work and we're able to provide you uh, um, this files is we're going to mount the backups from the backup repository, right? So we're going to take the compressed and deprecated backup file, and we're going to mount it to a specific mount server. Now, with version 13, you can choose the mount server to be a Linux or a Windows based on the OS that you want to recover from and to. Um, and we're going to browse those files. You will have a Windows Explorer that will allow you to browse the files that you need to recover, and you have multiple options. And from there, you can actually recover the data back to the production test or development environment, or even to your laptop or workstation, right? So you don't need to recover the entire VM just to access a specific file. The next option that we have is application items restore. I know that we spend quite some time into talking about guest processing and how we can protect those applications. So let's cover the restore option in here. So what we do with the application items restore is we launch specific explorers for the application that you need to run. You can see in this picture that we have selected restore application items, and because this is a domain controller, we have the Microsoft Active Directory objects that we can browse, right? The current supported applications are Microsoft Active Directory, SQL Server, Exchange, SharePoint, OneDrive for Business and Teams, but we also support Oracle and PostgreSQL, right? In the next picture, we do have an example of how these explorers look like. This is an explorer for AD, right? So we can see all of the entries in here, and then we can select an entry in here to restore the object to back to the original location, to a different location, and we can also export those objects. Something else that we have available is you can compare the object attributes just as well, right? But we have covered in big lines how you can recover, what are the options that you have actually on recovering. So let's actually cover how you can trigger, how you can start a restore, right? So this is the backup console, right? And we navigate in the left hand side, we need to navigate under the jobs to the backups, and you can select exactly from which location you want to restore from: snapshots, disk copy. Those are actually copied over from one location to another. So we have another copy of the data, object storage, and tapes, right? You can either choose the virtual machine in the right-hand side and then go to the left-hand side to the upper menu to recover the virtual machines, and you can choose the options. What I usually do is just I right-click on the virtual machine that I want to recover, and I choose the recover option from here because I can actually see all of them. Now let's start an entire VM restore, right? So after starting the entire VM restore, the first window that we're going to see in here is the virtual machine that we have picked to restore. We can also add different virtual machines, or we can select a point. So let me just show you exactly how it looks like. Um, after clicking on the point to select the restore point that we want to recover, we're going to have this list of all of the available backups that we have. And yes, we do have some backups here on tape just as well that we can recover from, right? All by default, Veeam is going to take the most recent restore point to recover, but you can also choose a different restore point if that's what you're looking for. Clicking next will reveal the restore modes. So we have multiple restore modes in here. So let's explore them one by one. First, we have the restore to original location, which can also use a quick rollback. Restore to original location, I feel is pretty straight, self-explanatory. It's going to quickly restore the virtual machine back to the original location with the original name and setting, so you can actually replace the damaged one. And quick rollback will only restore the changed blocks only. So it's going to allow for a quick VM recovery in case of guest OS software problems or user errors. Um, but this is not a suitable option for recovering from disaster recovery, from disasters or hardware or storage issues or even power loss. right? In those cases, we can actually use the secondary option, which is restore to a new location. Now be mindful of the left panel in here. If we choose restore to original location, we have the restore mode, the secure restore. Of course, we're going to explore that as well. But if I just go further and pick the restore to a new location with different settings, we're going to have more options in here, which makes sense, right? Because we're going to restore this virtual machine to a different location. So we need to be able to select the host first, where we want to recover this virtual machine, and then the resource pool, where we want to place this virtual machine. If I click next on the data store, we're going to pick the data store where we want to place this virtual machine. And we can also select the disk types in here, right? So we have the disk types, same as the source, thin or thick with lazy or eager zeroed. After that, we will just name the virtual machine. You can either add a suffix, or you can just change the name entirely, and you can change the folder where you want to place the machine. And if you had any VM tags, you can also recover them by clicking this button right here. The next topic that we have, actually the next option here, is network. So we can actually just map the network from the new host to this virtual machine that we're going to restore, or we can disconnect the virtual machine entirely, right? And then we have the secure restore, which is the option that we had even with the back to original location, right? So in here, what we can choose is, before recovering any data to a location, any location, we can choose to scan those backups. By default, you can scan those backups with Veeam Threat Hunter if we have the essentials or advanced um, product. If not, you can use your own antivirus. Whatever goes for the organization, Vim is fully supportive. We're here to help you protect your data and to even scan it, whatever antivirus you choose. The secondary option here is scanning the restore points with the YARA roles, right? We're going to cover YARA roles in a couple of seconds, but just know that you can also use those YARA roles for content analysis of the backups if you want to look for specific information prior to restoring the data. Now, the scan options are the following. If malware is found, we can either proceed with recovery but disable network adapters, just so we can isolate that suspicious item that we have seen, that we have found, or we can abort the VM recovery. We can also choose to continue scanning all remaining files after the first occurrence, just so we know whether we have this replicated over multiple backups. By clicking next, we will specify a reason why we want um, to recover this virtual machine, and that's helpful for accountability purposes. And then we have the summary, where we see everything that we have selected and configured in here, right? So we have the original machine, which is named DC01. The new machine name will be new underscore DC01 underscore restore. This is what we have edited. Which is the restore point that we're choosing, the target host, resource pool, VM folder, target data store, just as well as network mapping configurations. And we can choose, we can also see the scanning options that we have found. With the proxy, that's going to be on automatic selection, of course, right? And by clicking finish, we're going to trigger, we're going to launch the restore option. Next, security. By the way, if you have any questions regarding what we have discussed so far, don't hesitate to reach out to us. You can either just post your question in the chat, or if you have any additional questions, you can always just reach out to your account manager or to your renewals representative. But now let's dive into the security options that we have. So the first one that I wanted to talk to you about is the security and compliance analyzer. So Veeam Backup Replication provides a built-in tool to help you have a guideline over how um, you can harden and you can harden and you can um, secure the VBR server as much as possible. It includes 14 security checks and 23 production checks. And uh, in the next animation, we should actually have a screenshot of how it looks like. Now, the button, I have not covered it. It's in the top menu of the Veeam Backup Replication console under Home. And once clicking it, it's going to immediately start analyzing the infrastructure. It's going to show you a green or a red X if this has been detected, if it's been implemented or not. And we do have multiple options in here, right? Security best practices, secure boot should be enabled, firewall should be enabled. And we can scroll down to even MFA being enabled for the backup console, which is included, by the way. We're going to talk about that in the next slide. Immutability should be enabled. Password loss protection, that is a mechanism that we offer through Enterprise Manager, right? And the backup server should not be part of the domain. You can see we have multiple other options. You can always just reanalyze if you know for sure that you have changed something, but it's not popping in here. You can schedule this analyzer to uh, run at specific times so you can receive an email notification with the result. Or if something in here does not fit into your protection strategy, for example, backup server should not be part of the production domain, but you do have a backup domain, so it's a separate domain, it's not the production one, then you can actually suppress that in here. We do advise carefully considering all of the items and recommendations that we have in here, but it's definitely your call as backup and security administrators. Now, the next option here is multi-factor authentication. So we do support multi-factor authentication for the backup console, which is designed to generate a one-time password within the mobile authentication application that is used as a secondary verification option. So this is actually in the users and roles that we covered at the beginning of the main menu presentation. So under users and roles, we do have the users, and on the lower half of this window, we have the enable multi-factor authentication, right? Once enabling it, it's going to be enabled for all of the users that you have in this list. And the way that it works, so that it works fully offline, is at the next login of your users, they will be prompted to scan this QR code, which will register some predefined codes, right? And every time that they need to log in, they will need to type in the username and password and use the code that will get regenerated on the mobile authentication app every 30 seconds or so. The secondary security option that we have in here, it's past the roles, it's under authorization. Um, And this is a feature that will prevent any accidental or erroneous deletion of backups, entire backup repository, changes to users and roles. Um, so basically anything that can be performed that could be potentially harmful for the environment will be restricted by this feature. The way that it works is if your backup administrator or security officers, which do have a higher level of privileges on the consoles, need to do something that can be potentially harmful, this will be actually requested and need to be either approved or denied by another admin or by another security officer, right? Here are two pictures that show exactly how those requests look like and where you can actually see them with the pending approvals on the home panel, top left corner, basically. Um, you can also choose these requests to expire after a period of time. And of course, it makes sense that the backup admin that requested that issued the request cannot approve that request. However, they can deny their own request, but this will leave traces. You can see that in the history, or you can see that into the event viewer logs of the virtual machine of the backup server, whether it is a virtual machine or a physical server. So you will be able to have some, accountability in here. Um, right, and the next topics that we have are malware detection mechanisms. So Veeam is indeed focused on detecting malware and suspicious activity in both the production and the backup infrastructure, and of course, sending notifications about it. We have started releasing malware features on version 12.1 that can help even identifying the sleeping malware in production. So let's dive into those features and let's see how they work and what they actually are. So the first one is on-demand scan for malware and content. This feature will focus on already existing backups and will allow you to scan them with the antivirus or with the YARA rules into making sure that you don't have any traces of malware activity um, into those backups. It offers three scan modes. We have here find the last clean restore point, pretty self-explanatory. Find the last clean restore point in range, and in the lower half of this window, we do have the range that we can choose from most recent to oldest, or from a start date to end date, which I believe is useful if you know that you had maybe a suspicious event, I don't know, yesterday or last week. And then the third option here is scan content of all restore points in range with the YARA rules, right? If you're not familiar with the YARA rules, those are options for backup content analysis um, that can help you look um, for specific items, right? You can actually look for personally identifiable information, personal health information, or whatever you design those YARA rules to uh, to do. In the scan engine, you can choose whether you want to run with Threat Hunter, which by the way can be modified. You can use your own antivirus if you want to. And you can also choose to use Yara rules. You can either use all of them or just one option in here. That's also going to be fine. And there's another option of continuing scanning all remaining files after the first occurrence. Now, this option that we have talked about is more or less a manual process. So whenever you see a suspicious activity into the backup console, and we're going to get to that in a couple of minutes, whenever you see this activity, um, this flagged activity as a suspicious one, you can trigger, you can launch that process. However, you can also automate this process to be ran into a sure backup job, which will also leverage the antivirus and the YARA rule, so it will have pretty much the same options. And when creating a sure backup job, I know that Gabi uh, covered the sure backup. We have two options. So we have full recoverability testing, running the machines into an isolated environment and verifying the recoverability of the backups, or we can have backup verification and content scan only, which will only impact the backups from the repository, and we'll scan them with our options. Configuring it is much easier than configuring a share backup job because you don't actually need a virtual lab in here, right? So what we're going to do is we're going to link specific jobs that we're going to use. Again, the same option as share backup, add, remove, set up exclusions, or the process of the virtual machines that you want to work with. And then under settings, we're going to choose the content analysis to scan the backup content with the Veeam Threat Hunter, or scan them with the YARA rules. And of course, the same options apply in here. We can continue scanning all remaining files after the first occurrence, and we can also do the backup integrity check. If you recall on what we discussed when we talked about the backup job options, right, under advanced options, we also have this integrity check. So you can schedule that into the sure backup job just as well. And because we have talked a lot about how you can verify the already existing backups, I guess it's time to actually start looking at the production data and how we can make sure that, first of all, we don't have that into the backups, or we are aware that there is something going on with our backups without needing to just blindly scan them, right? So Veeam has released multiple features in this direction. You can see them in here. The first one is encryption detection. This uses a trained machine learning model, an AI, how we like to call it, um, uh, and um, and the low impact entropy analysis to to detect any previously unencrypted data that became encrypted on the disk into your production virtual machines. It does have multiple sensitivity levels from low to normal to extreme, of course, another one in between. And depending on how you slide this button, you can actually choose, you will actually utilize more CPU on the proxies. So this is a process that is going to be injected on the proxies additionally. And this is what's going to run in conjunction with compression, deduplication, and transferring the data over the network. Once activating it, just keep in mind that the first job run will not use the change block tracking. It's not going to create an active full, but it needs to populate, the hash map that we have. It needs to populate to know exactly what are the data that we're looking for, right? Now, let's have a look at how exactly this will run in production. So we have a nice schema in here, a nice diagram if you want. And let's imagine that this print screen right here is actually the production data. This is actually just a print screen of the properties of the backups. So during the backup data, what we're going to do is first we're going to use the backup proxy to use this inline detection mechanism to scan those backups, and then we're going to compress them, deduplicate, and send them over through the link. If nothing suspicious is found, we're going to store the data into the backup repository. However, if there is some suspicious activity, we're going to notify this possible infection to the backup server, which is going to flag those infected backups into the repository, as you can see in here, right? And from here, we can leverage one of the two options that we have discussed so far on with on-demand scanning or sure backup scanning for optimized purposes to actually verify what's the suspicious activity that we have detected in here, and if you truly are targeted by any malicious um, attackers or organization out there. Now, in addition to looking for encrypted uh, data, we also look at the files that you have and the activity that you have on the files in production, right? So what we do is we do file system activity analysis, which will detect the appearance of suspicious files and deletion or renaming of large number of files, which can be a sign of um, malware activity. But we also look at the indicators of compromise detection. So what this does actually is it will detect early indicators of compromise. And we're actually looking at hacker toolkits out there that are commonly used. So we are sure to identify them prior to actually, exploding and um, damaging the infrastructure that you have. Now, under signature detection, we actually have the detection engine that I've been talking to you about. We can either choose to use the Veeam Threat Hunter, which is our own antivirus, right? Our own signature-based antivirus, or you can choose to bring your own antivirus. What's new in version 13 is we have this proactive investigation where we instruct Veeam to perform the signature-based scan when malware events appear based on the previous scans that we have talked about. And we can also mark those as clean if no threats are detected with this scanned backups. If any questions pop up regarding the malware detection mechanisms or anything else, feel free to ask them into the question box. Now let's talk about some tips and tricks that we have for you. So the first tips that I want to give you is the quick backup and the Veeam zip. So the quick backup will offer an on-demand incremental backup for a VM without setting up a new backup job. So it's basically going to continue the existing backup chain, but it's just going to create a new incremental backup, just as this diagram shows. And then the Veeam zip will actually create a full backup with no backup job of a virtual machine. Scenarios where I think this Vim zip is useful is if you want to decommission a virtual machine and you want to have a one last backup of that virtual machine. It's going to pop up under backups, disk exported, because you can take it anywhere and you can recover it again if that's what you need to. Now, here is one example on where you can see those options. So those are going to be found under inventory. Look up for the virtual machine into the vCenter server, and then if you right click on that, you will have the Vim zip or quick backup that you can execute in here. Enterprise Manager and vCenter. So at Veeam, we have a plugin for VMware vSphere client, which streamlines the backup management for vSphere admins. It basically lets you check Veeam backup and application status, monitor job outcomes, and view storage statuses directly from the vSphere client. It does have some configuration details in here and some requirements, but you're also going to have the requirements in the uh, last slides where we have included some resources. Copy and move operation are also two powerful features that we have released, which were heavily requested by our clients, so about you guys. And those are the options that we can use to move backups to different repositories, move backups to another job, copy those backups. So basically, lift and shift your backups from one location to another, and even migrate them from REFS to XFS for hardened repositories, or from NTFS to REFS if you want to upgrade the repository that you use, the Windows repository that you have used. In the next couple of animations, we do have an example on how this looks like. So once triggering a move or a copy operation is going to ask us the destination backup repository that we want to place these backups in and the folder, right? We can also choose to delete this backup automatically, but we also have a background retention which should take care of that if those jobs still exist, right? The Vim extract utility is a nice overlooked feature that we have, which can work as an independent tool for recovery or through a GUI or CLI. So basically, this utility will help you recover data from the backups without having the Veeam Backup Replication installed. So you can actually just shift this backup. You can use the previous options, the move operation to move your backup to another location, and then you can use this extract utility to recover uh, the backups that you have, right, from that specific backup. And I know this training took some time, but we are almost done. Something else that I wanted to share with you are our hands-on experience labs. So those are a set of labs that you can request. Most of them have availability of 4 hours, and you can actually use them to test drive our features and our products without creating a sandbox environment in your own um, infrastructure. So you can utilize them. You can either just scan this code or go to this link or even just Google Veeam hands-on labs and you're going to see them. They are very well indexed. Um, and if you found information in this training useful, we can also recommend you to consider the Veeam Certified Engineer Certification, which has instructor or on-demand um, on-demand options. It's available in 100 countries. It contains theory and labs. And here is an additional resource, the link that we can use to kind of read more about it, including the Veeam University. Some additional resources that we have added in here are the on-demand trainings, the calculators that you can use for capacity planning and forecasting, help center articles, best practices, KB on knowledge bases on security, our R&D forums and community resource hubs. I do advise you to utilize those as they're frequently monitored by our product managers, right? So you can actually get in touch with them. Much easier, I mean. Um, and if you do have uh, a success, successful story, we do encourage you to share it with us. You can actually feature on our website, on social channels. You will have speaking opportunities at VMon events, showcase your expertise within the community, and get the kudos for your accomplishments. Now, if you're interested, feel free to reach out at advocacy@veeam.com, or you can just let us know in the chat. All right. Those being said, thank you so much for your time, for your availability, and we're hoping that this training, you found this training um, full of precious knowledge, maybe, and that we offered you some values in here. Thank you so much.